Is this working? Yay, it's working. Good morning, everybody. How's everybody doing? Pretty good? Okay. Welcome to the final day of the Telemetry Workshop Series. Yeah, I have a few things that I'll talk about, but I think I'll talk about those at the end. One thing I do want to say is a few of us are going to a hockey game tonight, Moosehead's game. If you didn't get an email from me this morning and you were expecting to go, let me know as soon as possible. If you didn't get a ticket but you want one, also let me know within the next 5 minutes, because I can possibly contact the guy and see if there are any spare tickets, but that's the best that I can do. We're switching gears today. We're going to be talking about communications and collaborations. And so we're starting off with communications to a scientific audience. And so Rob Lennox is a fantastic writer. I get him to proofread almost everything that I do, whether it's blogging or paper or whatever. I find him to be an extremely effective communicator of science, and so I, of course, wanted him to help everybody and to talk to you about his different views on writing papers. He has so many different ways that he goes about collaborating with people and organizing papers, and he has a lot of experience as a reviewer as well, so he's bringing in that experience as well. And today he's going to be giving just some tips on how to present your scientific information, mostly within papers, but just in general to a scientific audience. So thank you, Rob.
Thank you very much, Kim. So when I was in high school, I really didn't know what I wanted to do or what I liked to do, and I really wanted to be a marine biologist, and I didn't know if I would get there. And my second choice was journalism school, because the only thing that I thought that I could ever really do effectively and enjoy was writing. And when I was making those decisions as a 17-year-old, which is a strange time of your life to be making really consequential decisions about where your entire life will lead you, I kind of thought that if I could write all the time, I would be really happy. But I thought, playing in the ocean would be a lot more fun, and I left that behind. And somewhere along the line, those paths kind of merged, and I realized that I was naive, and I didn't realize that a huge part of being a scientist was actually writing. And when I realized that it was, it really sort of solidified for me that it was potentially a good path. So I've always enjoyed writing. I've practiced it a lot. I've developed that skill as much as I could. I've worked with some incredible writers and gotten advice and tips from some of the best in our field, I think. And it's something that I'm passionate about and really interested in and trying to actively develop. And I think there's a lot of lessons that everybody can learn about writing. And here are some. I put together some slides about some of my experiences writing, as well as being a reviewer on papers, and trying to notice the challenges associated with scientific writing and some of the opportunities to effectively communicate. And let's put together a quick slide about what we're trying to do. So we're trying to publish research that's relevant and interesting, and we want to address a certain audience. So we want to address stakeholders, in particular, people that will use the knowledge that we're producing. So writing effective papers and communicating these lessons that we're learning from research is extremely important. And I think all the time about the millions or billions of dollars of research that's on floppy disks or in file drawers that isn't mobilized and isn't available to stakeholders or potential knowledge users. And it's a huge inefficiency. So part of the reason that I'm very passionate about publishing papers is simply the realization that it's the only way to ensure that the investments that we make, our time and money and effort and energy and all the late nights spent working and worrying about how projects will go, it's really the best way to ensure that that research becomes usable, not only within a couple of years, but potentially, many years down the road, potentially past our lifetimes. And so I think scientists have an obligation to publish research in order to develop this knowledge. And I strongly believe that everything is is publishable. Essentially, almost essentially everything that we do adds knowledge, and somebody can find use in it. And then it's really important to take it seriously and realize that even when you get negative results, whether you get inconclusive results, there's often lessons, and depending on how you communicate that and the lessons that you're able to find in that, you can address a specific audience that can benefit from that. So we're never trying to write the perfect paper, in my opinion or my experience. It's about trying to write an effective paper. So we want to just communicate the results clearly. We want to make data available, so not just the findings, but ensure that the raw data are archived and available to future users for things like meta-analyses and synthesis projects. I want to connect it with other relevant research, both within the field and beyond the field, and create opportunities for future research that can build off of it. So some myths, I think, about scientific writing that I've seen during my time doing it, that publishing research is difficult. I don't think that's necessarily true. It's just that it takes practice. Everybody that I've ever worked with has gotten better at writing over time. It's not because it's an extremely challenging endeavor. It's merely that there are certain rules and guidelines, and when you follow them, you can write an effective paper. Peer-reviewed research is the gold standard. In fact, I think it's just the starting point for generating knowledge. Having a peer-reviewed publication is not the end of the road. Communicating that research and sharing papers with intended audiences and building off that knowledge with future research, connecting it via meta-analyses and review and synthesis and perspective papers is really important. Replications and null results are not interesting. That's totally untrue, of course. The replications and null results are critical to advancing science. Doing these experiments is a really important role for scientists to have in making sure that it's publishable. I talk to people all the time that get rejection letters, unfortunately, from journals that justify rejections because they're replications or their null results, and I think that's, in my opinion, in my experience, that's not an effective way to be conducting science, to be closing the doors to people that are doing these really important projects. And expert researchers plus peer review produces flawless research. There are a lot of mistakes in published papers. You need to read these papers with a critical eye. You need to think about the conclusions that people draw. There's an idiom, I forget where it's from, that you should not attribute to malice what can adequately be explained by incompetence or lack of knowledge. People make mistakes not necessarily because they want to, or they're lazy, or they have malicious intent, but because mistakes happen, and it's not always a bad thing. Pointing those out and being critical with other people's research is a good thing. I took my first year at university here at Dalhousie, I took a class from Tim Jukes on scientific writing, and I learned a lot about writing in that class, and a lot of those lessons really only crystallized years down the road. So these are some things that when I read papers, kind of drive me a little bit crazy. Misusing spatial and temporal terms. The wrasse swam as it was startled. We read things like that all the time. It's better to say the wrasse swam because it was startled. Using while is a temporal term. So while the findings are conclusive, more research is needed. There's really no need for a temporal term there. Although the findings are conclusive, more research is needed. I find to be a more effective way to communicate that statement. Confusing which and that. I see this a lot in research and journalism and writing. The fish which was tagged. I find that a very difficult to interpret sentence or statement. The fish that was tagged is more effective to me. And always using serial or Oxford commas when listing. So the tag had temperature, depth, and acceleration sensors with no comma I find very difficult to understand what's going on there. The tag had temperature, depth, and acceleration sensors, I think is more effective. So some tools for effective writing. I use Google Docs almost exclusively now for writing scientific papers. I didn't always, but it's really streamlined to a huge extent the way that I write papers, especially collaborating with other people. Sending around one version and having people comment on it is very difficult. You have version control issues. You have some people that are really busy and they delay the process by a month or more because they don't get back to you. Google Docs, you can send out a link to everybody. Everybody has access. You can tag people in comments so that they get an email so they know exactly where in the document they need to address. It backs up online automatically. There's version control so you can go back and look at previous versions. it's just a really effective way to write papers, and it can shave off almost half the time that it takes dealing with collaborators and comments, because everybody can work on it simultaneously when they have time. If they have the link, they can sign in, or they can log in, or they can open it up whenever they want, and it usually gets done a lot more effectively that way. You can also access them offline, so it's not only online. You can get the version online, and when you sign back into internet, the changes that you've made will update automatically. Some that I don't use as much. Zotero is apparently an excellent open source reference manager. A lot of people use EndNote. I've never really used reference managers, although people seem to love it. Zotero is apparently a really good alternative. GitHub, I'm going to start to learn to archive version and version control my code. Jake mentioned that briefly yesterday. I think it's a fantastic tool, and I need to develop those skills. R Markdown can assist with R workflow. I don't use it personally, but there are apparently a lot of benefits. Same with the R Shiny app and some other tools within R, and Zenodo for free data archiving. So obviously we all use Ocean Tracking Network database for telemetry data, but other data that are not necessarily specifically related to telemetry can be archived for free in Zenodo. So writing strategies, when I work with people, the number one thing that I always recommend is start a working document as soon as possible. It's a living document, and you can always build on it. So the first thing that I do is usually try to write out methods, because it's the first thing that's conducted in a study. When I'm out in the field, I start writing the method section so that it's already done. I find it's way easier to build on a document than to start it from scratch. So conducting a whole study and then opening up a blank Word document is very stressful. It's hard to remember exactly what I did. It's hard to remember exactly the story I'm trying to tell. But when I have a living working document where there's already text in there, I can scroll down to wherever I find text that sort of hooks me in, and I read a sentence, and all of a sudden I'm ready to go from there. I read something, I can build off that. I can work with that. I read something about that last week. I was talking to somebody at a workshop about this paper. I'm going to go find it. I can cite that here, things like that. When I'm reading, no matter what I'm reading, and I come across something that is potentially relevant to a paper that I'm writing, I immediately open the working document and I write a sentence out that approximates what I'd try to say about it, and I add in that citation and the reference. So I never have to go back, or rarely have to go back and find what I was reading 2, 3 weeks or months ago. It's already in there, and I can modify the wording, but I have an idea of what that citation is saying. As I'm doing that, and I'm reading through my working document, I start to reorganize sentences, things that go together, get matched together. Paragraphs form. Paragraphs get moved from introduction to discussion. Methods are already there. As I'm doing data analysis, I'm adding in results, and the paper basically writes itself in that way. Writing out discussion bullet points whenever they come to mind. Often when I'm writing the introduction, I'm thinking about things that could be potential discussion topics, and I just write that in the discussion as a bullet point. Potentially as a header or a topic sentence for a paragraph about limitations to the study or future research directions. I find the introduction and the discussion are often very complementary, so information that sometimes I write initially in the introduction, I think, no, I'm going to save that for the discussion. It's really more of a future direction. Adding and modifying is just always easier than starting from scratch. Titles I find very interesting. I have I'm really interested in hanging titles because you see them more and more. There's some really funny ones, fantastic yeasts and where to find them, about the hidden diversity of dimorphic fungal pathogens, and then ones like boomeranging around Australia, historical biogeography. To me, I find the fantastic yeasts and where to find them very on the nose. I think it's funny, it's clever. Boomeranging around Australia, I don't really understand. I don't see how anything to do with equatorial fish has anything to do with boomerangs, but so whenever I'm looking through titles, I often see some that I find very funny or not very funny, and I send them around because I think there's a very clear distinction to me between which ones I like and which ones I don't. Titles should always be informative. If you've read some of the articles that I've written, you see that a lot of the titles are basically just statements of fact or finding. They're not very creative or clever, because I just try to think about what search terms people might use if they were trying to find the information in the paper. I use Google Scholar personally a lot, and that's how I build my titles, basically, is if someone was interested in this research, what might they search? What would I search? research should be fun in many ways, I think. So hanging titles can be fun and lighthearted. They can also be confusing. There are, I think, 5 papers that build off the Hobbit there and back again about salmon migration. So at least be unique. If you have a clever title, then that's awesome, but try to make it stand out. Nobody is likely to be searching in Google Scholar there and back again to try to find a paper about salmon migration. Most people will only read your abstract, so I think you should spend a disproportionate amount of time ensuring that the abstract provides clear information. Even people that are going to cite your paper, they may only read the abstract, so always be strategic in the information that you provide in the abstract, such that you want to make sure that the key results are described in enough detail that somebody can cite it if that's all they've read. So there's people going to be scanning through your abstract, just looking for a citation for a statement that they've already made, and you want to be able to hook them in. Common mistakes I find when I've read abstracts as a reviewer: excessive background. Really, the results are what's important. Nobody's going to read your abstract or cite your abstract based on what's already been done. Too much methodological detail. Again, focus should really be on the results. If people are you want to hook people into the methods and get them into the paper to read the whole paper. So if they're really interested in the methods, you can pull them down to the main text. And results are often understated, making it difficult to cite. So I've emphasized that a couple times. But if you don't really emphasize what the result or what the results or the findings are, then a lot of people will pass on your paper quite quickly, unfortunately. And lacking key conclusions and implications. Most introductions, I think, are generally too long. A lot of journals now have really strict length requirements. Probably that it's not just now, but I'm just starting to notice it. I try not to waste words on the introduction as much as possible. We had a great talk from Andrew Hendry, who's at McGill, while I was doing my PhD at Carleton, and he suggested 3 paragraphs for your introduction, a very simple system. The baby, the werewolf, and the silver bullet. You describe a system or something that people care about, something that's threatening that system, and then in the 3rd paragraph, you set up an experiment that's going to figure out how to resolve or better understand that threat to that system. Almost all the papers that I write, I aim to write one single spaced page of introduction. Sometimes it bleeds down to about 1.5 pages, but for me that's as much as I think most people are really interested in reading, and it's usually enough to effectively communicate the introduction material. Tailoring the introduction to fit the journal. If the first paragraph is about fish, it's usually going to be best suited for a fish journal. Thinking about exactly how you want to frame your study, I think, really makes a difference on how you begin your introduction. The first paragraph, in my experience, is really critical to where that paper ends up going. If you want to publish a paper in a journal like Ecology or Journal of Applied Ecology, Ecological Applications, American Naturalist, your first paragraph really needs to focus on something about ecological theory and something like density dependence, something that or biogeography or landscape energetics, some theory that you're explicitly testing. That's how you can hook reviewers or editors in and convince them that you're using a model system, maybe a fish telemetry system, to study this ecological question, but the paper is really about this. So that first paragraph is really how you frame, that really determines the fate of the paper in my experience. Final paragraph in an introduction is most challenging. Avoid stating a statistical hypothesis. When I'm a reviewer, I often see people talking about null hypotheses and alternative hypotheses. Not really an effective way to outline an experiment. I usually lean towards making predictions instead of hypotheses because they're much easier to understand and they're much more clear. And you need to transition to the method section smoothly, but not really describe methods in detail. So you can talk about how telemetry is a perfect system to test this hypothesis, and then get into the methods as a nice transition. But it's not necessary to go into great detail about the number of receivers and the number of fish that are needed or used in order to conduct a study. Just quickly interject upon my own talk that, of course, these are general guidelines, and I believe very strongly that all advice is based on survivor bias. What works for me does not necessarily work for everybody else, and I wouldn't advocate to do things exactly as I say, but pick out things that you think are interesting and that work for you. You have a question, Jay?
Sorry, I didn't mean to
Yeah, so Jake recently gave me some great advice on cover letters. I always put effort into them, but probably not nearly enough effort. What Jake suggested to me was to really focus on other literature that had addressed a similar topic that was in the journal that you're submitting to, and discussing exactly how your paper sort of interfaces with those papers that journal has already published, but builds upon the knowledge. And I think that's really good advice, because it really can hook in an editor to say, well, I handled that paper. It was a good paper. Like, let's see what this paper now has to offer. I think that's definitely good advice. Thank you, Jake. Method sections are of extreme importance. For some reason, they're last in some journals in Nature and PNAS. That always throws me off. It's ideal to divide these into different sections. So study site, study species, experimental design, data analysis. Breaking things up into subsections makes it much more readable, I think, especially because these sections can be quite technical and potentially quite long. And many readers will be particularly interested in specific subsections. Some will really want to know what you did for data analysis. Seeing it smoothly or clearly described under a subheading can be very helpful for some readers. Data analysis section should provide the perfect template for reporting results. Just do it in the exact same order. It really doesn't have to be complicated. When I write a data analysis section in a methods, in parallel, I start writing out the results, and I can fill in what the p-values and the test statistics are later. But oftentimes when I review papers or read other papers, the data analysis is scattered within a method section. And when you're reading the results and you're trying to go back and you see a p-value or a test statistic, and you're like, okay, which test exactly was this? Was this the linear model? Was this the mixed effects model? Was this the GAM? It's not really clearly laid out. They're all jumping around in the methods and jumping around in the results, and you can't match them up. It's just easier to make sure that they align pretty perfectly, and you can go down the list in both and say, okay, this was the first test method. This was the first test result. This was the second test method. This was the second test result. It makes everything shorter, because when you do it that way, it becomes much more concise, and it makes everything much more readable. Data analysis section should really focus on facilitating replication. That means citing R packages. And in my opinion and experience, I always try to cite the R functions. When I was first starting out with writing papers, I would read something and think, wow, I could do that with my data. It's a great analysis. And then I could never find exactly what they did. I had to do a ton of Googling to figure out a complementary method, and not even know if it was the same thing. So I always put the function in there, so if somebody is reading my paper and they like what I did, they can go to that specific package and look at the exact function that I used. And I think that it's important for facilitating other people to be able to understand what you did, both for replication of your own results as well as replication of your methods for their own study. And I think hopefully, I don't know, no one's ever come up to me and said this really helped me out, but hopefully at some point somebody looks at it and says, okay, now I can do this with much greater efficiency. Results should be the easiest section, simply because it should just follow the methods, the data analysis section. You've already laid out exactly what you're going to do. There's no discussion, there's no interpretation, you're just saying exactly what you got. Avoiding imprecise statements about p-values. About 20% of the papers that I review simply say p was greater than 0.05. It's just not an effective way to communicate. It's way easier to just give the equivalency, p equals 0.16, whatever it is. As well as the test statistic. Long sentences is a clue that information could be stored in a table. Oftentimes when I see sentences that are going 3-4 lines in a results section, a lot of that information should just be transferred to a table. I use tables with great reliance, and it's important not to restate information in tables and figures that in the text. Just refer to them, and refer to them in parentheses, not directly. So activity increased with temperature, figure 1. Not in figure 1, we see how activity increased with temperature. Discussion, I always use the first paragraph to emphasize the key take-home messages. If people read your paper, they're going to read, like 90% of them are just going to read the abstract. The other 9% are probably just going to read maybe the first and last paragraph of the introduction, probably the first paragraph of the discussion, and definitely the last paragraph of the discussion. So if I need to know a key result, I go straight to the last paragraph of the discussion, sometimes the first paragraph of the discussion. So ensuring that the key information is there, I think, is quite important. You can divide this into subheadings. Certainly for writing, it can help. You can get rid of them later if you want to, but ensuring that it's sort of following a logical order and that the information is contained within sections clearly is crucial. And the final paragraph really needs to sum up all the paper. You can put it under a conclusion subheading or not, but really many people only read the last paragraph of the paper, or at least look there for the study's ultimate finding. And that's not just my own experience. I've been told that by others as well. I'm going to start flying through this now because I realize that my time is getting short. So making figures is the most fun part. Maps are fun and easy to make with ggplot, as I showed 2 days ago. I really like making colorful plots, but they're expensive to publish in journals. There's more and more online journals that don't care, but I've started just submitting color figures and saying, publish this online color only, and in the print version you can publish it in black and white, and there's in brackets in the figure title it just says refer to online version for color. So I had a quick exercise which was too ambitious to look at some Crocs data from the VTrack package and look at all the different ways that we can visualize the data. So one question of what's the depth distribution, how does the depth distribution of these crocodiles differ? There's a lot of different ways you can plot it. So you can plot it with points, where I've used geom_jitter. So instead of having them overlap, you see the distribution, and you can say the day and night is colored differently. You can have a continuous path track of the depth. You can look at the mean and the standard error going up and down. You can make violin plots like this, where you have densities. So you can see the day and night densities of the two individuals. You can have ridge plots, which are conceptually similar to the violin plots, but flipped up and overlapping a little bit. You can have box plots. That's all essentially the exact same data, the exact same question. There's a lot of different ways to plot it, and you need to think critically about the best way to present that information. And oftentimes it's quite important to communicate the data as honestly as possible, which means showing the variability. So in my opinion and experience, I find box plots tend to hide the data a little bit. I like violin plots a lot. I sometimes use ridge plots, but it always depends on the question. So if you get really lucky, sometimes you can get a really good shapefile. When you're working in a new spot, I think it's the first question I always ask is, can I get a shapefile for this? Otherwise, I got to use something like ggmap or marmap. Selecting a journal. Andrew Hendry has a great long series on this in his blog. He always suggests aiming high because there's a low cost of failure and a high benefit of success. He also suggests society journals because the fees go back into society. So journals like conservation biology, the fee that you pay goes into the Society for Conservation Biology. Open access journals are often expensive. Some differences in editorial experience. So some journals, in my experience, like Frontiers in Ecology and Evolution, I'm pretty sure their editorial manual says you basically can't reject a paper if you're an editor because their business model is publishing papers for money. They're often corporate, like Frontiers and PLOS, but there are some great free options for open access journals. So I love Boreal Environment Research. It's free. It's open access. You can publish in it for free, and everybody can read it. It's run by the University of Helsinki, I think. The competing factors are time it takes to get it finished and published, so you don't want to be just resubmitting a paper 15 times until it gets accepted. And 2, impact factor, personal goals, visibility. And of course, beware of predatory journals. It's a waste of resources. It's bad for science. You can often spot them, but they're getting harder and harder to find. So this is an example, the International Academy of Ecology and Environmental Sciences. If you're unsure about a journal, then talk to your advisor, email people in the field, contact the editor of the journal, get more information. And my conclusions, enjoyment of science is often reflected in the quality of the paper. So hanging titles can be fun. People seem to love them. Hidden allusions in the paper. I have lots of people tell me that they hide references to Bob Dylan and Hitchhiker's Guide to the Galaxy. Colorful figures, that's what I really enjoy. I like making nice plots and maps. Simplifying the message, that's crucial. Ensuring that anybody that's wanting to get information from your paper can access it very quickly and easily. It helps it be read and cited and shared. Get feedback early and often. It's never too early to send a draft around. I'm sure everybody's heard that, but it's really true. the easiest way to improve is to get feedback and to practice. Describe data analysis in detail. I really can't overemphasize that. It's really difficult to read a paper where you don't actually know how the data were analyzed. Use subheadings. Breaking up the paper is effective. A lot of journals have clickable subheadings, so you can actually navigate through the paper fairly efficiently just by getting the subheading that you're interested in and going through like that. And sink your teeth in. That just means writing as much as you can, starting early, having a living document, often in Google Docs I would recommend, that you can add to, that you can add references to, that you can start making sentences in, that you can write a method section early on. The quicker that you embrace the process of writing a paper, the more efficiently you will be able to do it, and the less difficult it will be. Writing a paper is really not hard. It takes time and practice, and I strongly believe that everybody is capable of being an excellent scientific communicator. And I hope that some of these things have been interesting or new to you. I don't think I have time for questions, but let's talk about it in the afternoon potentially.
Thank you so much, Rob. I'm just going to add one more thing. So get feedback early and often. Also offer feedback early and often, right? Like that's part of what we're here doing. We're creating networks for ourselves. So we're all in the same boat here. And if you guys want to learn, I'm sure other people do too. So just seek those people out and offer your feedback as well.
Help everybody.
Yeah, just help. Let me just see if we can get this next one up. SciComm. #SciComm. The presentation is called #SciComm. That's incredible. Sorry, Joe, I think I got this. Play from start. I'm being tested. Fine. Boom. Okay, so yeah, it should be fine, just the arrows. All right, so now we've covered communications to a scientific audience. We're going to switch gears, and we're going to cover communications to basically everybody else. So it's my absolute pleasure today to introduce to you Anya Samardzik and Maggie Sutherland. They are the two sole members of the comms department here. They have 2 positions open if anybody is interested. One position open, sorry, if anybody is interested. These ladies, I've had the pleasure of working with them for the last 4 months very closely. Thank you so much. They are in charge of making OTN look good, and they do it extremely well. I cannot emphasize how good these ladies are at their jobs. Everything that we've been able to pull off today has been because of them. And when I asked them to give this talk, I really said, I really want people to be aware that when we're talking as scientists, when we're talking to people who aren't scientists, we can't just rely on our science to make us look good, because not a lot of other people will be able to understand that, okay? So you really have to put a lot of effort into your presentation when you're talking to industry, when you're talking to government, when you're talking to just the general public. And so these ladies have all of that experience today, and they were a little nervous when I asked them to talk. They were saying, maybe you should ask somebody who's more scientific. And I said, no. This is exactly what I want, because I have a feeling that it's not really on anybody else's brains. I had no idea. That we had to actually work really hard to make this stuff look good and learn a new design program and stuff like that. And so they're just going to share a couple of words of wisdom today, and I really greatly appreciate you guys coming in today. So thank you very much.
No problem.
I can't say enough.
Okay, great. So good morning. My name is Anya Samardzik. I'm the communications manager for the Ocean Tracking Network. I have a background in international development studies and public relations, and OTN is the perfect place for me to merge my interest in oceans conservation with my skills and passion for communications and design.
Hi, I'm Maggie. I'm the Communications Coordinator with OTN. I have a BSc and MSc in Geography, and I've worked for several conservation-focused charities, and I love working at OTN. I started here in the fall because I get to merge my scientific background with the creativity and communications and my passion for ocean conservation.
So as Kim mentioned, we're a two-person team, and we're just going to talk to you today about the kind of communications that we do for the network in hopes that it will be of value to you when you're sharing your own research. So given that this is day 3 of the workshop, you likely know about OTN already, so we'll just dive into the communications aspect here. So given our global reach, we have a lot of different stakeholders that we work with and a lot of different deliverables and outputs for the network. And our main goal really is to develop, manage, and leverage activities and outputs that serve the strategic goals of OTN, and that includes working with internal personnel and also with our collaborators from local to global scales. So we have a lot of different deliverables, including but not limited to annual reports, government and facility tours, public outreach and engagement events like booths at the farmers market or movie screenings. We do media relations, digital and media marketing, sponsorship development, and as Kim has already mentioned, event planning.
So science communication is communicating science-related topics to stakeholders. It is disseminating this knowledge to bridge the gap between researchers and the stakeholders and really bring research studies and results into the public sphere. Stakeholders can include, but aren't limited to, government bodies, funding agencies, public institutions, media outlets, and the general public.
So there are many different types of science communication, and science communication really should engage and connect, and this can be done in a number of different ways. So it can be done through traditional communications like media and news coverage. This could be articles on the web or print, radio or TV appearances. You've got online and social media communications, which I'm sure most, if not all of you, already use. So websites, social media platforms such as Twitter, Facebook, and Instagram. And then other communications such as novel projects and campaigns that we'll talk to you about in a second. Presentations, outreach opportunities, reports, papers, pamphlets, panels, movie screenings, facility tours, and even field trips. So I want to start to talk about novel outreach opportunities because we've had the great fortune of having a few of them here at OTN. So one of our really cool novel outreach opportunities is the Tag Your It beer, which I'm sure a lot of you have tried. It's so we've been doing this project now for 4 years and running, and 50 cents from each can of this beer goes to oceans conservation initiatives in the Maritimes. So we've managed to connect with a lot of different local ENGOs who are doing some great work in the province, ranging from blue shark conservation to salmon conservation. And the beer is called Tag Your It, and that's because when Rick Mercer, pictured on the bottom here, went shark tagging with our executive director, Fred Wariski, his closing line was Tag Your It. So that's what we went with. And then we've also got, last year we had a really amazing opportunity to work with Mattel and National Geographic for the launch of their conservation Barbies. So they came out with a series of several dolls, including a marine polar biologist Barbie, and our scientific director, Sarah Iverson, was chosen as the mentor and the role model for this campaign. So there were a lot of different communications that came out of that, including a ton of media coverage, an amazing video for the Barbie YouTube channel, a field tagging trip, a blue shark tagging trip, And also Sarah was invited last year to the Halifax Chamber of Commerce Wonder Women Conference, where she talked about her work and about this campaign. And at the end of her talk, Oprah Winfrey style, they gave out 400 Barbies to all of the conference attendees. You get a Barbie, and you get a Barbie, and you get a Barbie. It was amazing. So even if you're not working on projects of this scale, you may be asked to participate in projects of this scale. So we've got Shannon up here demonstrating how lobsters tagged, and then we've got one of our field technicians, Nate, helping with the shark tagging. So always keep in mind that there are opportunities to think outside of the box and that you might get asked to participate in them.
So a significant portion of SciComm actually occurs online. 45% of the global population uses social media daily, and 90% of this is millennials who are active an average of 3 hours a day. So digital media can include web content, that's articles, blogs, video, or the use of social media channels. And using social media or your lab or institution's website to curate stories about the research you're doing and the people involved is a really great way to demonstrate your work. A couple examples here. This is a blog by an OTN researcher, Xavier Bordelot, highlighting his work on the Kerguelen Islands, and this was a series that appeared on the OTN's website and uses really accessible language, conversation style, really easy to read. So that's a great way to leverage your work, is to use your institution's channels to share that story. And then also we have a little clip here showing a Twitter contest with a funding agency. So this was a recent opportunity where researchers could submit a short video about their work, and that actually was a chance for them to enter this contest through that short video. They got to have a chance to win a trip to Ottawa actually through this. So it's always great to gather these clips together. You never know when you might be able to use them to share the story about your research. So why do science communication? We spoke a bit about it already, but it's really an opportunity to connect with the stakeholders via online platforms, to use tools like Twitter and Facebook to tag and inform various levels of government, industry, and academia, and also the public about the importance of your research. It really helps to build online communities for information sharing as well, and collaboration. So if you're starting from scratch on social, there's no need to do everything at once. You might start with a platform that appeals to you the most, see how that goes, and then expand from there, or not. It's okay just to do one of these and choose that if it works best for you. So disseminating knowledge and research in an interactive way helps to facilitate this two-way dialogue. Sharing your information, you can respond to questions that are out there about your work, and also receive comments through digital platforms. And it's also a way to connect with reporters who use these channels frequently. Online science communications is also a way to capitalize on the direct linkages between stakeholders through organizing events or groups for information sharing. You can demonstrate these activities through private tours of your lab, perhaps, presentations, participating in various public outreach events. Science communication can also directly transfer academic research information and results to stakeholders through publications and articles, and also network activities. So it's really important to build a portfolio of science communications. This can be helpful in applying for grants, awards, and also training opportunities. If you haven't started already, it's a great time to begin tracking any media coverage that your research might obtain. Also, you can track the reach of your social posts. You can get this through any insights available through these platforms. And so by tracking all of these stats on media coverage and reach of your posts, it really helps to demonstrate the impact of your work, and this is something that you can roll into any funding application.
So why do online science communications or science communication writ large? And so Maggie discussed that, but how do you start doing that? Well, there are a couple of key factors to keep in mind. One is to know your audience. So always ask yourself, who is my audience and what do they already know about the topic at hand? Because this will really affect the kind of language that you use and how you center your communications. And also be really mindful of your language. You know, if people are new to what you're discussing, you might use animal tracking rather than telemetry, for example. Pull out some key messages. So as Rob mentioned earlier, what are the salient points of what you're trying to get across? Take those key messages from your abstract or your central thesis and pull them out and make them accessible. You know, put them front and center of what you're trying to say, because they're really the most important takeaways and the core of what you're trying to communicate. So is it easy to understand? Is it meaningful? Does it include the who, what, when, where, why, and how? And are there human and environmental implications to be mentioned when you're discussing this work? So, you know, ask yourself, why does my research matter, and how do I get that across to whoever might be reading it? This was just one example for you about how to center key messages. So it can be really complex to demonstrate what your organization or your institution does. And last year, OTN put together a 10-year report that summarized a decade worth of research and activities. And so we were asking ourselves, you know, how do we frame what we do in a really simple and accessible and interesting way? So we came up with Track, Connect, and Transform. And it says, together OTN and its collaborators are tracking oceans, connecting people, and transforming knowledge. So what do we want people to know? We want them to know that we track animals across the globe. We want them also to know that we connect people, resources, infrastructure on local to global scales. And that we're also transforming the data management paradigm as well as our understanding of the oceans and how we can best steward and manage them. So this is an example of taking some really complex concepts or large chunks of information and making them really succinct and easy to understand at a first glance. This was one example that I had pulled out in terms of just the use of language, because another big barrier to science communication is the type of language that you use. So take a couple of seconds to read these two pieces of text, which convey the same type of information in two very different ways. And so ask yourself, you know, when you're developing your own materials, what is my material for? What's the publication? Who's the audience? And how do I ensure that my language is accessible and or appropriate to what I'm doing? So how do we overcome some of these barriers for effective science communication? Well, we can start by normalizing our research a little bit. You can use a funny anecdote like #fieldworkfail to tell a story or talk about why your work is interesting and use it to relate to your audience. So here I've pulled up two tweets from the Twitter archives. One is of our very own Rob Harcourt, and it says, 2 weeks on an uninhabited island, forgot the cutlery, #fieldworkfail, and he's actually eating dinner with a clamshell. And then we have another one here that says, just admiring my excellent camera placement. And as you can see, it's not so excellent. So it's really such a cool way to facilitate two-way dialogue about what's happening in the field and lessons learned. And that's a great way for researchers to share their work and also their innovations as well. Again, a huge one, know your audience. So for a general audience, just assume that the understanding of the language and the concepts are low. Try to look at it from a grade 8 level or lower, which is usually what media uses. So keep it short, keep it simple, keep it to the point. Lose the lingo, and remember that less is more. So try to keep it simple. The average person has a really short attention span and very little time. And so do you want your audience to understand what you're saying the moment that they read something? They shouldn't really have to do more than one read through, because you've already lost them if they need to read something more than once. You can also make your work visual. So a lot of people get their information from watching videos or looking at pictures. So, consider making a short video or posting some pictures to create a photo gallery of what you're doing, because it really can draw people in. And we'll chat about that a little bit more.
Another mode of communications that we mentioned earlier is traditional media, and within this is working with media outlets, that's TV, radio, and print. So building a relationship with media contacts is a good starting point in changing the way that media understands and reports on your topic. Media influences the public and creating a feedback loop and overall public perception. So these headlines here that we've listed on the left show examples of when media clearly ran with the story, or when media outlets, reporters reached out to researchers or institutions and they developed the story together. Media coverage provides organizations with a direct link to the public to deliver information in a cost-effective way and a timely manner, because newsrooms operate in a very fast-paced environment. If you're concerned about commenting on a contentious issue, you can always get a head start by publishing your own story through your own channels, and then you can pitch this angle to reporters and work with them to develop the story how you would like. Keep in mind that traditional media outlets use social media a great deal to find stories, so be sure to use all the channels possible to get your message out there. Also, don't be intimidated to reach out to media about your story. They could be looking for something just like you have to cover. And if not, there's always a slow news day where they could fit it in. When reaching out to journalists, keep in mind that it's really important to email individuals, not just sending it to a general newsroom. And also, the first sentence in your email should really be a pitch about why this story is relevant, why it's important to them, why they should cover it. They're not going to read beyond that first sentence, so if you start off that way, then have your full story below that. That's a great way to grab them. Also, follow up. They receive hundreds of emails a day. Just because they didn't respond doesn't necessarily mean they don't want to cover your story. It could have just gotten lost in the mountain of email. Visual communications are a really key component to effective science communication. This includes photos, graphs, tables, infographics like this one here. And these can all be used as social media graphics as well. These type of punchy illustrations can really demonstrate complex concepts in an engaging and very simplified way. So you can apply this to many different communications channels, like social media I mentioned, strategic reports. This could be part of a paper and used in an outreach event or a conference. The design of these pieces is really key. The fonts that you use, the colors, the layout, this is all really important to keeping it simple and conveying the message that you want. So when you're creating something for a particular project or a poster, keep in mind all of this. You want to choose a consistent layout and stick with that. As Kim kindly mentioned earlier, Anya and I helped out a bit with the design pieces for this workshop series, and you may have noticed that we chose a theme and we stuck with that in the conference schedule, on the website, and the in between part to the live stream. So keeping that consistent theme really helps to relay your message.
So we don't have a lot of time left, but we'll leave you with some tips and tricks for good and easy hashtag SciComm. Again, know your audience, understand what they already know, and make sure that your language and your key messages are accessible. Less is more. I think in university we're taught that word count is really important, and we're always looking for more of it. But when you're looking at communications materials, you really want to make sure that what you're conveying is short and punchy and just straight to the point. Key messages, what are the core takeaways that you want people to know? The who, what, when, where, why. Why does it matter for science, and why does it matter for society? Keep those in mind when you develop your communications materials. Use visual aids. So there are a lot of amazing free stock photography websites like Unsplash, where we got this sea lion. Canva, it's a great software online to develop any type of design graphic that you need, and it's free and super easy to use. Get creative. So there are also free video editing tools that you can use, like Lumen 5 and Wave. They're amazing for taking your B-roll and your photos and doing really short clips for Twitter, Facebook, or Instagram. And then lastly, connect with communicators. So if there are communications personnel at your institution, reach out to them and let them know about what you're doing, because they're always looking for a story, and they're always looking to share your research with the world. And the same goes with the media. I mean, they're always interested in knowing about what's happening. So it never hurts to reach out and pitch your work to them. So here's just a list of SciComm resources that you can use, and you'll be able to click on these links when you get the slideshows at the end of the workshop. And so there are tips and tricks for design software, good design, video editing, and media pitching. And that kind of concludes our presentation for today. So if you have any questions for us or any examples of how SciComm has worked for you, we'd love to hear from you. Otherwise, feel free to email us at any time if you have additional questions. Thanks.
Thank you so much. Again, ladies, we do not have time for questions, but I just want to stress, I feel like I personally cannot stress enough, I really think that we just can't rely on just our research and just our science to be able to effectively communicate our results. So what you guys do is so important, and just thank you for coming and talking to us about it. Next up, we're continuing on with the collaboration theme, and it's my absolute pleasure to introduce to you, are all four of you coming up? Awesome. Okay, so I have the great pleasure of introducing to you guys today four researchers from the Unama'ki Institute of Natural Resources up in Eskasoni, Cape Breton. And I've had the pleasure of working with Tyson and Angela before. We did some Atlantic salmon smolt telemetry work up in this beautiful spot, the Brador Lakes of Cape Breton. And I've only just recently met Skylar and Jennifer, but I'm hoping we get to collaborate in the future. From these collaborations, I've really just taken away that I've had so much fun and I've learned so much, and I really wanted to share that with you guys all today. And so they're here to talk to you about collaboration with Mi'kmaq. So please welcome.
How you doing? So I guess Kim, we've seen worked with Kim for a while up at the smoke wheel there. I just want to say, before we begin, I want to say something about. So I would like to begin by acknowledging that we are on the traditional and unceded territory of the Mi'kmaq Nation. Hold on. So from 1725 to 1761, the Mi'kmaq and British Crown entered a series of treaties that are known as the Peace and Friendship Treaties. The Mi'kmaq treaties are about friendship and diplomacy and maintaining and structuring relationships between diverse nations, Aboriginal and European. The treaties establish political order intended to prescribe nation-to-nation relations in the context of coexistence, not to surrender land or resources or as subjects of the British Crown. Traditionally, Mi'kmaq territory is referred to as Mi'kmaq and has 7 divisions: Halifax or Jibuktuk. Jibuktuk means the Great Harbor, that's Halifax. is part of Esquiwa, Skin Dressers Territory. We will touch more on Mi'kmaq in a bit. Okay, I guess we can begin. Okay, so the title of our presentation is Collaborating in Mi'kmaq, Concepts, Approaches, and Challenges. So our titles up at UINR, me, Jennifer, and Angela, we're integrative researchers. We switched from, we're research assistants, we had discussion, we wanted to be like say a biologist or something like that, but we came up with integrative researchers because we use both integrative knowledge, like two systems. So we gave ourselves our titles as integrative researchers. And Skylar, he's a collaboration with Skylar's title. What is it again? Community liaison with OTN. Sorry, I forgot. Okay, today we'll talk about UINR. We'll talk about Mi'kmaq people. We'll touch on two-wide scene and collaboration challenges and Aboon Madultinesh. That's what Skylar's project is with OTN, and we'll talk about that more. So, UINR, Unama'ki Institute of Natural Resources. Sorry. What's going on? Okay, it's all good. So, our organization, Unama'ki Institute of Natural Resources. So, Unama'ki means in Mi'kmaq, it's Cape Breton. So, we're based in Cape Breton. So, UINR represents Unama'kis, Cape Bretons, Mi'kmaq Voice of Natural Resource and Environmental Concerns. So, UINR, we're governed by. That's the next slide, right? Oh, yeah, okay, sorry. So today, 50% of status Mi'kmaq in Nova Scotia are currently from Mi'kmaq communities in Unama'ki. Unama'ki, we're governed by the 5 communities in Cape Breton. There's Bodlorek, there's Membertou, there's Eskizoni, there's Wa'amukuk, and there's Wergo'ama. But there's also Maligawach, but Maligawach is governed by all the 5 communities. That's not a community, but we consider it as a community. So UINR, our 3 goals is to provide resources for Mi'kmaq, equal participation in natural resource management in Unama'ki and its traditional territory. To strengthen Mi'kmaq research and natural resource management while maintaining our traditions and world views. To partner with other groups sharing the same desire to protect and preserve the resources for future generation. So that's our main focus when we work with other organizations. That's our main goals with UINR. So in our division, the Aquatics Research and Stewardship, we use a lot of science paired with Mi'kmaq traditional knowledge is the key to UINR's aquatic research activities. So whatever we do with science, we always try to involve Mi'kmaq traditional knowledge. And because when you look at Mi'kmaq traditional knowledge, it's really, really important when we're moving forward in the science department there. And that's why our aquatics research and stewardship group, we got to where we're at now. So UINR's research is guided by our communities and the advice and guidance of our community elders. Also, UINR's research is guided by communities, but also from traditional fishermen. That's where we gather all our information from. Like, let's say we work with lobster or work with eel. We also get the science and biology and stuff like that, but in order for us to get all the traditional information, we have to talk to the fishermen, the Mi'kmaq fishermen, and those are the ones that are giving us the most information. So, because like when we go out, let's say I go out, I want to go get some lobster or something like that. For me, I really wouldn't know where to go. But so we're in contact with the Mi'kmaq fishermen a lot, and they let us know where they are, where to get them, and stuff like that. Like Skylar's are really, really important with UINR because he helps us a lot with traditional fishing too and Mi'kmaq knowledge. So as Mi'kmaq people, the Mi'kmaq Nation belong to a much larger tribal group known as the Wabanaki Confederacy, which included the Mi'kmaq, Maliseet, Passamaquoddy, Penobscot, and Abenaki tribes of the eastern North America. Pre-contact, the Mi'kmaq Nation was divided into 7 districts, each led by a district chief. Together, they made up the Mi'kmaq Grand Council, which governed by consensus over entire territory and its people. Oral history and archaeological evidence placed the Mi'kmaq in Mi'kmaq for at least 13,000 years. So, the Mi'kmaq Nation was orderly, well-governed, strong, acknowledged, and successful. The traditional Mi'kmaq Grand Council continues to exist, but its authorities to govern has been largely transferred by the Indian Act to the elective chiefs and councils of each community. So we switched over from a lot of it from traditional Grand Council. Now it's chief and council that are elected from each of the communities. So this is a map of Mi'kmaq. So here's a map of Mi'kmaq. There are approximately 35 reserves scattered across Mi'kmaq. So 13 in Nova Scotia. Each community has its own leadership known as the Band Council, with an elected chief and council, several councillors. The nation has a population of around 170,000 people. Point out and so next Angela will talk about Mi'kmaq rights and reconciliation part there. Responsibilities, yeah. Each of us has be good if each of us talk about each part of the presentation here.
Thank you. Okay. So I'd like to talk a little bit about the concept we have called Nedogalimk. We view the world and all that is in it as having spirit. We consider all life equal to our own and treat it with respect. We developed an intimate understanding of the relationships between the living and non-living so that each plant, animal, constellation, full moon, or red sky tells a story that guides our people so they can survive. I'm going to wait for it. It goes twice. Okay, these beliefs affect the way we treat the natural world for sustenance and survival. Animals and plants are not taken if they are not needed. All spirits are acknowledged and respected as relatives and are offered tobacco, prayer, or ceremony, or a combination when taken. No part of an animal is wasted. All parts that cannot be used are returned to the Creator. The consciousness is described by the Mi'kmaq word Nedogalimk. Mi'kmaq rights. The Aboriginal right to fish for food, social, and ceremonial needs. This was determined by the Sparrow decision in 1990. Treaty rights to fish for a moderate livelihood. That's the Marshall decision in 1999. Both rights are protected by the Constitution Act 1982. Both have conservation as a way to infringe or violate those rights. Conservation is the case made when the fish population doesn't have enough fish to sustain that population. The Mi'kmaq right to fish for food, social, and ceremonial needs and for a moderate livelihood is recognized by the Supreme Court of Canada and is protected by the Constitution Act in Canada. Here we have this is the annual harvest for the annual St. Anne's Mission in Chapel Island in Bodlodeg. And there's a feast that's done after they clean the statue of St. Anne, a feast is held. And this is where they go to, this is from the Margaree River.
This is from the hatchery pool.
The hatchery pool.
Seine in there. As you can see, we caught a lot of brown instead of salmon. Way a lot of brown and speckled.
So they caught about 2 salmon.
We only see two salmon, large salmon, compared to like 30, 40 trout there.
Okay, Mi'kmaq responsibility can best be summed up by our elder advisor, Albert Marshall, who says, Mi'kmaq carry a great sense of responsibility. As all life is our relations, any loss of life is a loss of kin and spirit. The unintentional eradication of species is deeply connected to loss in cultural identity. Time on Earth is merely borrowed from future generations. As such, the Mi'kmaq have the inherent responsibility to ensure all of nature's gifts are there for the next 7 generations. And the next 7 generations translates into 140 years. We have a slide here on the Mi'kmaq creation story. This illustration here is the creation of Glooscap and the Mi'kmaq by Gerald Glode. The image shows Glooscap creating harmony and balance with all our relations. So the Mi'kmaq creation story describes how life began for all things. This process occurred in 7 stages or levels of creation. The story tells about the relationship between the Great Spirit Creator and human beings and the environment. It also explains a philosophical view of life which is indigenous to North America. If you would like to learn more about Mi'kmaq values and beliefs, read the Mi'kmaq creation story that Stephen Augustine explains it very well. Okay, we don't have time to watch this today. It's a 13-minute long video, so I'd like to just talk about this. So the video is called "We Are All Treaty People." It illustrates the joint commitment from the Mi'kmaq community and the province of Nova Scotia to deliver treaty education to all classrooms, grades, and schools, to the general public, and to all public servants across Nova Scotia. Treaty education refers to the process of creating a greater understanding of the Mi'kmaq, of inherent Aboriginal rights, recognition of the peace and friendship treaties as historical and living agreements, and continuing the relationships between Mi'kmaq and all peoples of Nova Scotia. So here is the website. If you want to look at that, it's on YouTube. Treaty education is teaching all Canadians who Mi'kmaq people are, where we've come from, and how we can all move forward together. Next, Jennifer will talk about another of Elder Albert's concepts known as two-eyed seeing.
Hi, I'm Jennifer. I'm going to bombard you guys with a lot of information really quickly. So I'm going to share Shelley, our supervisor, our boss's version of two-eyed seeing as an approach to collaboration. Most of these talks are 45 minutes to an hour long, so we're going to kind of cram this little section in about 20 minutes. So we'll see how that goes. So her talk draws upon peer-reviewed literature, experience, and her involvement in research partnerships such as FishWix, which is the Fisheries Western and Indigenous Knowledge Systems, to further enhance the application of two-eyed seeing. So the focus is based on several papers, setting the stage for Collaborative Coexistence, Advancing Salmon Governance in Nova Scotia by Shelley Denny and Lucia Fanning, Improving the American Eel Fishery through the Incorporation of Indigenous Knowledge into Policy-Level Decision-Making in Canada by Amber Giles, Lucia, and Shelley and Tyson, A Typology of Traditional Knowledge Literature by Nicola Tulip, and Two-Eyed Seeing and Other Lessons Learned Within a Co-Learning Journey of Bringing Together Indigenous and Mainstream Knowledges and Ways of Knowing by Cheryl Bartlett and Merdina and Albert Marshall. So this overview will focus on a few things, but in detail, the idea is to provide you with an understanding of two-eyed seeing as an approach to collaboration, but we'll be doing it differently than how others present two-eyed seeing. We're going to focus on knowledge systems. I'm going to clip this on me because it's annoying to hold. Okay, there you go. So we're going to focus on knowledge systems, both Western and Indigenous knowledge, and how different cultures through their knowledge systems collide. and we'll provide guidance on how two-eyed seeing, for two-eyed seeing and ways one must prepare for this journey. So Albert's concept on two-eyed seeing is world-renowned. It refers to the gift of multiplicity. Albert doesn't tell us how to do two-eyed seeing, but he does give us guidance. So he says two-eyed seeing refers to learning to see from one eye with the strengths of indigenous knowledges, and from the other eye the strengths of Western knowledges, and using both of these eyes together for the benefit of all. Albert tells us that two-eyed seeing is about co-learning. It's about the opportunity to co-produce knowledge using the best of Western and Indigenous knowledge. But what we've learned is that it is an approach for which collaboration can and should occur when collaborating with Indigenous people like the Mi'kmaq. Two-eyed seeing is a process. Collaboration is a process as well, but two-eyed seeing is a particular type of process. It is collaboration, but through learning, and it's a way to co-produce something new. One thing that we learned is that it is contextual and is not one size fits all. What it isn't is it isn't reliance on Western or Indigenous knowledge. It isn't cherry picking, prescriptive, or gap filling. Fundamental to two-eyed seeing is knowing what knowledge is, whether it is Western knowledge or Indigenous knowledge. The approach that we bring to two-eyed seeing is based on knowledge systems, not the knowledge itself. We prefer to think of knowledge as a verb. It's how we know rather than what we know. So when we refer to Indigenous knowledge, we often think of what we know, and it is to some degree. We see this in terms of local ecological knowledge, like where to find the fish or hunt, when, and the environmental cues that indicate when such an event is about to occur. But knowledge is a system, whether it is Indigenous or Western, community or institutional. The knowledge system is comprised of many things: what we know, how we practice our knowledge, how we adapt to it, and how we transmit knowledge are the elements most people are familiar with. But the values and the underlying beliefs that are also part of a knowledge system are often ignored. And this is problematic because often the values and beliefs are at odds between cultures, creating a barrier to collaboration. There are two challenges in a two-eyed seeing process from the beginning. The first is that we don't understand each other's knowledge systems. And the second is that we often don't understand our own knowledge system. So let's move to begin to examining what Western and knowledge systems are. So what is Western knowledge? Western knowledge is referred to as science-based knowledge. It is a systematic verification process to test questions from observations. Western knowledge attempts to produce empirical information that can be repeated or can be repeatedly generated and is designed to reduce bias. It consists of the scientific method of hypothesis development, design, execution, analysis, and interpretation. It is considered to be fully objective and indisputable. Current decision-making models in fisheries and government for resource management perspective is segregated and hierarchical, where science informs management. Are there values in Western science? There sure are. Western science values written transmission of knowledge. Western science values statistics. Western science values a certain way of knowing. What is Indigenous knowledge? Indigenous knowledge is somewhat more complicated. Nicole the Tulip examined the typologies of Indigenous knowledge in her literature and identified the strengths and weaknesses of the orientations, as she calls them. As four orientations, the first two in red, ecological and critical, refer to Western perceptions of Indigenous knowledge. Relational in blue is how Indigenous people describe their knowledge system. And in purple, collaborative is where we strive to be when we engage in cross-cultural collaborations where two-eyed seeing is the goal. It has no easy definition, not mutually exclusive, but they have different emphasis, each of them. So go into each of them. So ecological is the first one. Ecological orientations of Indigenous knowledge is viewed as a gap filler. It supplements Western science and offers insights to ecological processes. It is recently discovered as a form of adaptive management where knowledge could contribute to sustainable management of resources. The weaknesses of this orientation are is that it is extractive and reduced to observations and practices by resource managers. It neglects the living dimensions of Indigenous knowledge as socio-ecological interdependence and spiritual dimensions. Often ecological orientations are reduced to management rather than governance. The next one is critical. This orientation is embedded in uneven colonial relations of power. There are no strengths to this orientation, but it is imperative that one understands the role of power within and between knowledge systems. This perspective distorts Indigenous knowledge and reduces it to observations, resource management systems, and past and current uses. It overlooks the belief systems, values, cultural significance, social relations, and place-centered identity. Here, written knowledge is valued over experiential or oral knowledge. We often see this expressed as attempts to fit Indigenous knowledge into science, thereby reinforcing the hierarchical structure and power Western society exerts on Indigenous knowledge. So Indigenous knowledge is their relationship with the natural world. It is lived and it is what one does rather than what one knows about. It is distinct and highlighted as different from Western science. It is knowledge that is embedded in cultural frameworks that are rooted in the land and cannot be separated from the roles and responsibilities of the culture. Like other knowledge systems, it expands and contracts in relation to wider social and ecological processes. Indigenous knowledge systems in particular are driven by ethics as part of their value system, and governance is implied. In Mi'kma'ki, we have the phrase Imsidnogama, which literally translated means all my relations. It's our relationship with the natural world, the living, the non-living, in the temporal scales of past, present, and future. So this underlying belief is associated with a specific set of values, which we judge what is important and how we develop a standard of behavior. It's also not easy for just anyone to understand Indigenous knowledge. It requires Western scientists and resource managers to transcend worldviews and recognize the uniqueness of Indigenous knowledge as a standalone system. It is not universal or pan-Indigenous. It is place-based knowledge that may come from many sources. It requires empowered participation at multiple levels, decision-making, technical, and managerial. The last orientation is collaborative. This is a means of empowerment for Indigenous people as opportunities to influence environmental and resource management regimes. Some of its strengths is that it is process-based. It encourages research practices that build self-governance capacity and encourages innovative, transformative, collaborative processes. It aligns ethics with goals and values, and it's an invitation for co-learning and co-production to build adaptive capacity. It does, however, require a long-term view and institutional transformation to bring different ways of knowing together, so it can get complicated. So working between knowledge systems can be challenging. First, we have different values and beliefs. What we value informs what and how we do things, and this is a source of conflict and tension. Next, add incompatible knowledge systems. Western knowledge systems are based on post-positivism. Western scientists are trained and are products of institutionalized knowledge, where they're taught there is only one true way of knowing, that their way of knowing is objective, and it is reinforced by experts, scholars, and researchers and the institutions that they are part of. Indigenous knowledge, however, is relationship-based and can appreciate multiple ways of knowing, and that many people contribute to knowing. No one person can hold all the knowledge. Furthermore, you add the different orientations of Indigenous knowledge. Western science views it, or Western society views it and treats it very different. It reduces it and or exerts power over its use and credibility. Indigenous people do not separate what they value from what they know or do. Their knowledge system is the relationship to the natural world. These almost make two-eyed seeing impossible to undertake, almost. But there are secrets, if you will, to facilitating two-eyed seeing as an approach to collaboration. The first is to recognize that it is a process. It's a collaboration, therefore people need to work together. This then becomes the opportunity for co-learning. These processes are also necessary as Indigenous knowledge systems is not something you can learn about in a book. Here, methods of Western knowledge transmission don't apply. Incorporating and working in and among knowledge systems requires interaction. It helps to know that knowledge systems will collide. If there is no conflict or tension, then there probably isn't honesty either. So expect the tension and expect the conflict. The knowledge system approach is useful in dispute resolution. It lends itself to knowing that beliefs are non-negotiable, but values are. If we work together to recognize what the most important value or values are, then we have the opportunity to collaborate and integrate knowledge systems. This is the benefit of understanding knowledge systems in the context of two-eyed seeing. It's knowing where we can bend and where we can't. Using two-eyed seeing as a tool can also be helpful. Map it out to understand perspectives. UINR did this for the salmon consultation with the Mi'kmaq, DFO, Parks Canada, and the province of Nova Scotia Fisheries and Aquaculture. And it was helpful to show how different each knowledge system was, and that while we agreed that conservation of salmon was important, we realized that there are different ways to achieve conservation. And these were based on beliefs and values. Obviously, having shared values as a platform from which to work is less conflict-laden, but even if you think there are no shared values, remind yourself why you're collaborating in the first place. There is a shared value, otherwise you would not be at the table. And finally, the co-production of knowledge requires that one knowledge system doesn't replace the other. Here's where knowledge systems become integrated. Sometimes there's a tendency to go back to how you know what you know, and one knowledge system gets replaced by the other. That's not the goal in two-eyed seeing. Two-eyed seeing is an agreed path forward with negotiated values, and these values guide what you do and how, and forges the way for co-production of knowledge. Two-eyed seeing is not for the faint-hearted, it's for the big-hearted. It's for those who are interested, who care, and who are willing to put in the effort and dedicated to making things happen. So Shelley made this great little diagram to kind of explain the two systems and how they're different, but where they can meet. So two-eyed seeing requires preparation. Preparation is important. We suggest 3 steps to prepare for two-eyed seeing. 1, decolonize. Decolonizing is necessary for non-Mi'kmaq and Mi'kmaq alike. Western ways are ingrained in our education system and are institutionalized. Mi'kmaq are not immune to this. Decolonizing is about recognizing that there are more than one way to view the world, and the indigenous ways through the lens of relationships. 2, explore your own knowledge system. How do you transmit, practice, and acquire knowledge? What are your values and beliefs? Whose knowledge is valid or credible? Why do you accept or reject knowledge? And finally, be open and remain open to other ways of knowing. This will cycle you back to step 1. Remind yourself to decolonize, remind yourself of your own biases about your own knowledge system, and remind yourself to have an open mind. So next someone's going to talk about challenges to collaboration.
Here, I'll talk about that. I probably don't need that mic. Oh, there's people watching? Okay. It's just hard holding it there, huh? So, some of the challenges we have with collaboration with UINR are, so some of the most common organizational, cultural, interpersonal barriers to collaboration include the following. So, we have a lot of lack of respect and trust with collaboration. So, as Jennifer was talking about, when we have the Unama'ki salmon group there, the way we made that is because of the fishermen have a lot of trust in us. We got a lot of information from them, traditional knowledge. So how we came about that was trust. And as years came by, that trust finally came about making that group. Also, some of the challenges with collaboration is different mindsets. Everybody has a different mindset going into a meeting. Some person may think they have more knowledge, they're way smarter than you and stuff like that. So you got to put that aside. And poor listening skills. That's one of the most important I believe, when we have collaboration, because you don't want to be sounding too scientific when you're talking to a group of fishermen, right? You're not going to get anywhere with that. So also we have knowledge deficits, a lack of alignment around goals. So people always try to go around the goals. Internal competitiveness, information hoarding, organizational silos, and physical separation. Physical separation can be really, really hard too, because you're always emailing, you're always on the phone. But we always say, when you meet with the people, you always get way more information, you get more stuff done. Like, for example, when we work with Amy and Skylar, we have face-to-face meetings, and I find those are really, really, they improve our methods and stuff like that. So we came about this here with UINR, the partnership tenets here. We developed this probably this year, right? Yeah. So because we're starting to get so given the interest in two-eyed seeing, reconciliation, and need for many projects to collaborate and partner with indigenous peoples, we created a set of 10 partnership tenets to provide guidance on how this can be achieved with UINR. These tenets are based on Mi'kmaq values and experience and lessons learned when partnering with other organizations, building on the foundation of Mi'kmaq values of equity, and negligence, and the principles of two-eyed seeing. The following tenets are adopted by UINR. So when we do partners, we want to engage early. Co-development of the project is expected. We just don't want to be where, oh, we talk to a Mi'kmaq person here, that's it. We want to be involved in the project early. That's
The research questions.
Yeah, to create everything from the start. We want to be involved at the start. We just don't want to be that piece of paper where, okay, we talk to them, that's good, let's keep going. No, we want to be started at the beginning, like a Bohanamarut this year. Relevance of the project is key to our participation. The project outcomes must benefit UINR or the Mi'kmaq community interest. That's one of our main goals also. It's like we want to know what are we going to get out of this project. Partners must be based on equality. This is expressed as shared decision making. How the project is developed, implemented, and communicated must be through a partnership agreement integrated within the project. So we want to be involved from the start with the decision making, all the questions and everything. The preferred project governance arrangement is a steering committee. In this form, all partners have equal voice in the project implementation and co-development of research questions, research methods, and methodologies, products, and communications. The expectation is that the terms of reference will be co-developed with an emphasis to shared decision-making, roles and responsibility clearly identified, address how data is to be used and shared, and incorporation of a conflict resolution process. That's a lot of, but that's really, really important when we move forward. But also we want to be aware of like local ethics review. That's really, really important because every time we want to do a project, we have to send in an ethics application to when we're working Mi'kmaq people. Any project we do, we have to send in an application to the Mi'kmaq Ethics Watch there up in CBU, right? So research must be minimal impacts to environment, including to the species studies, community involvement, environment as example. We encourage potential partners to work with us to integrate ways we minimize harm yet the research criteria to ensure successful project. That's really important because we have a role in UINR where we don't want to have any casualties. We don't want to do any work within species like fish species where we're gonna kill them or where we're gonna like do any harm instead of like having a successful project. So that's really important there. And also we want to have like budgets co-developed. We want to have a voice on the budgets where the money's going to be going and stuff like that. And resources to hire a community liaison have been successful in past projects. Recommend to ensure the project is supported by resources necessary for its success. That's really important, and that's where Skylar came in with OTN there. We want to have a community liaison with any project we want to do. If we could, we want to hire a community liaison person. And that community liaison we want it to be Mi'kmaq person. Especially a Mi'kmaq speaking person if we could. Co-authorize the expected on primary publications, project reports, and gray literature. Any project-related communication product, websites, social media, brochure, posters must be co-developed also. So that's our partnership tenets. That's the 10 steps we look at before we do a project with any organization we have. Might it be like government or private or... Okay, Skylar would talk about this.
Hello, my name is Skylar Jador, and I'm working with the UINR and Ocean Tracking Network on this Aboan Madultig project. Aboan Madultig means we're helping each other, and it enables better stewardship of aquatic species through equal participation and engagement among Mi'kmaq rights holders, local knowledge holders, and academia. A co-developed approach to understanding the ecology of our land and seascapes enhances the quality of the information collected and ensures transparency and accessibility to communities that rely on healthy ecosystems. So the project is a part of the Bredor Lakes ecosystem and the Bay of Fundy, and Ocean Tracking Network hired me to be like the community liaison and the field technician. So Aboan Madultig uses the strengths of different knowledge systems or ways of knowing to document the movements and habitat use of gadak, which are the American eel, jagechk, which are American lobster, and bunamug, which are the tomcod. And so basically, I know a lot of people who fish traditionally through many years and like generations through time, and a lot of the people have these knowledge systems where they know when an event is going to happen. Like say, for example, the smelts, when they come up to the rivers to spawn, the Mi'kmaq know that the best time to do that or to fish for them would be when the dandelions starts sprouting. Another one would be when the frost starts picking up, then we know the tomcod are going to be spawning soon. And they know when it gets hot, the lobsters will be molting in the Bredor. And for the eels, it's all based on water temperature. So I don't know, maybe they didn't have any thermometers, so they would just touch the water and say, oh yes, the eels are going to come out soon. So, but yeah, so what we did was I contacted local fishermen to help me gather samples like lobsters and eels in the Bredor Lakes. It's kind of challenging with the timing we had because the eels are most numerous when it just gets warm enough for them to leave. So that would be the best time to fish. So we had a little challenge where the water temperature was like 24 to 28 degrees Celsius, and that wasn't really too healthy for the eels. But we got 18 eels. It was 18. Yeah, 18 eels tagged with Jof, and we have like 33 lobsters tagged. But yeah, these studies inform the Mi'kmaq and community leadership regarding aquatic resource and oceans management. So, oh yes, yeah, and all the partners involved are the UINR, the Mi'kmaq Conservation Group, minus the Ocean Tracking Network, Acadia University, the DFO, Dalhousie, and NSERC. And so this is the stuff that I did starting when I started, we deployed some receivers in the Bredor Lakes, and we have the gate system here with the VR2s, the auto release, and the VPS array is over here. Total right there would be 36 receivers, and we have 4 in total at the Iona Bridge, 2 north, 2 south, 1 outside the Benacadie Pond, 6 around Eskizoni in the Barishwa Ponds, and we have 2 at the East Bay Sandbar. And we did that in 2 days, and they're sitting down. And we caught 20 of our lobsters are going to be cut within the VPS, 20 more around the Iona Bridge. And so we tested the lobsters this summer because the local knowledge holders told us that the eels molt in the summer. So we went and sampled them out in East Bay. We also deployed the CTD within the VPS array. We checked for the shell thickness and all that, and we had a little workshop on surgeries with Dr. Chris Harvey Clark, and we tagged 11 eels that day. Well, 10 actually, because one of the eels was a little injured from something. But anyways, here's a picture of what we were doing in the lab. So the EFWC they loaned us their facility to hold the fish and the lobsters in like a holding tank. And we did the lobsters. There's my local traditional fisherman. His name is Blair, or Jof. And here's a tagged lobster that we recaptured this summer. And another thing we did, I didn't add any, because I didn't have any pictures on my phone. I had some technical difficulties, but we also planted receivers underground at 2 locations to see and track where the lobsters go during the winter. So we have 30 centimeters of mud. So we dig out the substrate using a post hole digger, and we placed 3 receivers. I think they're VR9s, I believe, at 3 different depths, right under the mud, 6 inches. I don't know how many centimeters that was, but at the very bottom, so we have 30 centimeters of receivers where we can detect the fish, how far they go, and we just want to listen to the fish while they're under the mud. And that's pretty much it.
You guys have any questions? So nobody had any questions? Yeah.
Thank you for a great presentation.
Yeah.
Most people in this room are involved with tracking stuff.
Yeah.
And the time scale of tracking studies presents a particular set of challenges about data sharing and information sharing, because it's such a long-term process. It often takes years, as you guys know, to get that information, to process it all. I was wondering, that can sometimes cause conflicts with stakeholders or non-scientists that expect information at a much higher rate. And I was wondering if you had any tips or ideas or strategies about how to deal with that.
That's where our partnership tenants agreement came from. Because it seems like all the time they just want to, seems like you don't want to rush stuff. That's the reason why we developed is sometimes we get projects where they're already 50% done of the project or 50% developed, then they try to bring you in, right? So some of the challenges are, that's where we said we want to be at the start, right? Like, for example, you said you're the scholars, they want, or like the the stakeholders, I try to say that stakeholders would want it to be rushed up, right? And so the part where we get to that stakeholders is where we wanted to be involved at the start. And if we're going to be involved at the start, we're going to have to take a much slower process. So, like, I guess they have their own process of what's going to happen. But that's a really big challenge, and we've been through that. And that's the reason why we developed it sometimes. Because there's some, back in the day, there were some projects where we just like rushed into it and we didn't get anything. No information or nothing from it.
One of the, I guess, the key things for us is we communicating, like from the very beginning, communicate like we're going to do this project, we're going to collect this knowledge, but it might take us a couple years before we finish and get everything and get results to you. So as long as, well, in our experience, as long as we keep people informed through the whole way and don't just like leave them hanging to the end, they're pretty understanding and they'll accommodate us. But like effective communication and just laying it out and not like it's lying, I guess would be, you're saying like, oh, we're going to get all this information this year and then maybe we'll get something to you in like the fall. You probably won't be able to analyze it all then. So, and if there are, you're expected to produce something and there are delays, because that often happens, just let people know. It's all about like trust and honesty and stuff and communicating. That's building that relationship and making sure people know what's going on, so they don't get mad or whatever.
Can you describe some of the particular work that you did in the planning process before you started the project in River Lakes that was particular to the fact that it's a collaboration?
Which project?
Skylar's project.
The one that Skylar's
Oh, there's one in Skylar?
Right on.
Can you repeat the question for the mic?
Can you repeat the question? For me?
What was particular about the planning process that incorporated all of the values and tenets that you were just talking about?
So the question was, what were the planning process before collaboration, how we got to where we are. It took a long time. A bone multi project is probably one of our biggest collaborations that we've done. And a lot of everybody involved never did anything so big like that, because most of them are here in Halifax and we're based in Cape Breton. It took a lot of meetings and getting to know each other, learning expectations from each other. It was kind of a little bumpy road in the beginning, but we got it all sorted out and everything's all great now and everybody's happy. But it took a lot of time, and getting just like face-to-face meetings is the most effective, and sitting down at the table and figuring out like what we need to do and how we're going to do it, and making sure that you're respecting what each people's knowledge system is and what they want out of the project. So I think that's good enough.
Yeah, that's how we came about our research tenants here, probably from this project.
It's one of them. There's other ones that led us to that too. So.
Any other questions? Yeah.
So last night we had at the panel, the term that was phrased was parachute researcher. And I gave a little bit of thought to that. I thought a lot of times if you are an early career researcher, you're brought in on a project that's already been established and potentially doesn't have the best relationship or working out of province. There may not even be tenants. How do you approach that initial meeting or that initial kind of face-to-face where you are that researcher parachuting in on a project that it's like, I know that we work with these people or have worked with them in the past, but I haven't met anyone.
Go out and meet them. If you're new, you got, and if you want it to be successful and you want the people involved to help you out and give you what the information you need, then go out and talk to them. Like, hi, I'm new here. I'm going to be doing this. I'm only here for a little bit of time or whatever. I'm going to get the results, and they'll come back to you. I'm not going to take your info and run away and never come back. But yeah, just go out and talk to people. That's all. Build that relationship and.
Yeah. So when you start talking to people, you get more trust from it, right? So when you start collaborating, you want to get that trust at the start first. So once you get that trust, then your avenue start opening up elsewhere. So I think that's where you're going with that question, right? So when you start off new, you want to meet people right away and introduce yourself, what you want to do. You don't want to leave anything in the gray area where you want to be more open, for me to say that. Any other questions? No?
That was a fantastic presentation. We got a short break now for coffee, and Dave Hardy from DFO is going to be speaking after the break. He's got a couple of things he'd like to demonstrate. So he's got some unique rigs for mobile fish tagging and helping out with telemetry. So anybody that wants to come up and see the designs that he's innovated here should come up and talk to Dave.
Yeah, I was going to do this after, but I got saddled with probably the most boring talk possible, so I thought I'd spice it up a little bit. So anyways, this is a mobile fish anesthetic delivery system. Everything you need to anesthetize, hold, and tag fish is in here. So it's something that I've MacGyvered over time. So I'm just going to, so you see it here, it's 38 pounds or something. But anyways, I'm going to set it up. You guys grab your coffee and stuff, and if you're interested, you can come over and check it out. It might give you some ideas, especially for remote field work and things. So anyhow, have a good coffee.
Thanks, Dave.
Can you fit a 4-foot bucket on that thing?
All right. Did everybody have a good snack break? I assume everybody had a good snack break. I talked to most people. All right, Dave, that was a really interesting setup that you have with the with your mobile tagging station. Definitely gonna come take a look at that again before we take it down. So when we started putting together this workshop, we had a lot of interest from Department of Fisheries and Oceans, and we were really excited by that because DFO is a huge component of science in Canada, particularly aquatic science. Many of us have very close connections with DFO, and DFO scientists are embedded within all of our networks. And Dave was particularly enthusiastic, and we're really excited to have participation from him and his group. And we asked if he would be interested in actually giving a talk at our workshop and participating, because we know that you have tons of experience, and a lot of people have questions about what it's like to work with DFO, and how can we have these amazing jobs with DFO. And we asked Dave, and he graciously agreed to give this presentation for us. So we're thrilled to have you guys participating. Thank you so much for supporting our workshop, and thanks so much for agreeing to share your experiences and give a talk with us today.
All right, so yeah, that was thank you for that introduction. So I work over at the Bedford Institute of Oceanography, which is the Maritime's head office for fisheries and oceans, in the population ecology division. So I've been there 10 years, and I work on marine threats to Atlantic salmon, and before that I worked on shrimp stock assessment for 5 years for the Eastern Scotian Shelf. So I wasn't sure on the timing of when I would get to show off my gear over there. If anybody doesn't know who this is, we probably can't be friends. I can't do the mullet anymore, but this is one of my heroes. So anyways, it's just something I wanted to throw in, and I think some of you got a chance to look at it, but that's the field fish anesthetic delivery system, which derives originally, the idea came from DFO course that was put on to try to achieve consistency in fish tagging methods between, first specifically, salmon telemetry projects that DFO is doing on Atlantic salmon. So the course was put on at UPEI, and they showed us this fish anesthetic delivery system based on that you plug everything into the wall. And I thought, geez, wouldn't that be great to have that you could take out with you away from electricity first, and then it evolved to be, well, what if you could just put it on your back and have everything you need? The only place, my work is not as intrepid as I would lead you to believe with that system, but sometimes just simple practical things, like we tagged on the Gaspereau River, and forgive the earlier talk about the importance of communicating with a non-scientific audience, but sometimes you just want to get your work done. So we were tagging on this river with a busy hiking trail, and the first day of tagging, I'm trying to concentrate on what I'm doing, and there's one after another person coming, hey, what are you doing over there? And asking you questions, and I'm like, what tag number? And it gets complicated. So I just put that in my backpack and crossed the river, and then I just waved. So it has various applications. Not all of them are, commando style. So I was asked to give a talk on sort of two topics, and one was on how to communicate with DFO management. And that sort of became a telling question to ask, because it sort of became clear to me that maybe there was some lack of clarity on what DFO management was. So I sort of had to ask the question, do you mean resource management? Or do you mean management, like the bean counters? Or do you mean Ottawa? So I'm going to talk a little bit about that, and then the second part will be the sort of insider's track on some of the things I've learned as an employee, but also as somebody hiring people on how to get a job with DFO. So one thing that's sort of important to remember, and you'll see it when I talk a little bit about the regions of DFO, but the type of work that some of us here do in particular is kind of unusual, especially on the Atlantic side of the country. So a lot more of the work that's done is at sea on marine species, and is often some version of fairly pure stock assessment to provide science advice for commercial fisheries and bycatch and things like that. So if you're like me, I mean, I get seasick in a hammock. So when I first started working for DFO, anybody who knew me was like, why would you do that, and why don't you go to Winnipeg? So I did put in my time. I managed to somehow smile in most of those pictures, but there's other ones. So anyways, that is just something important to remember, is that depending what you're working on in your graduate work, a lot of the work that DFO does is linked to a mandate to provide science advice for harvested species. So it's sometimes somewhat different, and sometimes the process of it is distinctly less academic than what you're used to. It doesn't mean there aren't academic opportunities, but I just wanted to flag that. So the structure of the talk is I'm going to talk a little bit about the first section, how to communicate with DFO management, which I put in quotes because of these uncertainties about what level of management we're talking about. So I'm going to talk about our communications office, our sort of media relations, which is interesting in the context of this morning's talk about SciComms and how different it is and how different it can be under different governments, of which I've experienced two very different ones in my short career. And then the communicating with science and research, which is, I think, probably where the question came from, and it's the aspect I'm most able to provide some feedback on. And then I just wanted to mention specifically what resource management is, and then what the overall management of DFO is, and where you may or may not want to be communicating with them. And then another part of DFO you might communicate with is the CSAS office, the Canadian Science Advice Secretariat. So I'm going to talk about that a little bit. And then HR did get wind. I didn't know this was going to be broadcast originally, but I'm still just going to go ahead. So HR got wind that this was going to happen, and they said, well, we should go and we should do it, and you know, because maybe it's a good recruitment event. And I took the liberty of telling them it was canceled, so they wouldn't come. But they, so if you guys wanted that, sorry, I took it elsewhere. But I think it's because if there's one thing I learned while my brain was on fire the last couple of days, is you are all like really smart people. So you probably can go to YouTube and put in how to get a job with the Government of Canada. You could Google. I think you can handle it, right? There's no GitHub even involved. So that, because what they suggested to me is, oh, here's a little video you could show, and here's a website you could go to. And I'm like, that's not going to be useful. So what I'm going to focus on is the second part, which I call the real skinny. So some of the things that are, some of them bridging a little bit on things I maybe shouldn't be as honest about, but let's do it anyways. So for regional considerations, I mean, one thing that sometimes people don't know, if you look at these maps, those are the DFO regions, and you can see that we're really heavy on the Atlantic coast with a lot of different regions. So that's replication of all that different organizational structure and management and research programs separately in Quebec, Newfoundland, Labrador, Gulf region, and Maritimes. So I don't know if that's anything I can do about that. I'll try a little farther away. So it's relevant because the sort of complexity of making connections. If you think you may want to live in Atlantic Canada and you may want to work for DFO, there's a lot more people you need to be speaking to than, you know, you've got a great contact that can probably get you in the door to talk to people in Winnipeg, and you can see you've got a big part of the country that you can work in. So it is different across the country, as are a lot of things about it. So it's all DFO, but the way things are done and the emphasis on stock assessment versus like on the Pacific coast, you know, I mean, it's, you could almost call it the Department of Salmon at times, right? It's a different ballgame than it is elsewhere. So that's just something important to realize. And then NHQ, that's national headquarters, that's Ottawa. And I'm not going to talk a lot about how to interact with Ottawa because I tend to avoid it. But that's a lot of important things happen there, I'm sure. But no, our opportunities at our level to interact at that level are pretty slim. It can be really interesting if you are invited. It's a real eye-opener to go and see how people at that level, what kinds of things they're thinking about and how different it is than what we're doing day to day. So yeah, so our communications themselves, we have a communications office in every region and a national office. And so that's some along the lines of what we heard this morning. There's their page, they've got all the social media stuff. So if you're looking to communicate with communications, that could be in a couple of contexts. So that could be that you have done some research and you want DFO to know about it. So I get emails from our communications, anything to do with Atlantic salmon, work that's happening, or a cage that's ruptured that shows up in the media, and sometimes it's researchers who have reached out and flagged something to communications, and I get it in my email. And so that can be somewhere that if you contact them with research news or questions, you can be involved that way. It was interesting in listening to this morning's talk about how much this encouragement with scientific communications to just put yourself out there, and that is one thing that can be quite different when you're working for DFO. Generally, you do need to involve communications, and although under the current government you don't necessarily have to. So I had a CBC reporter contact me last spring, and he came out and he interviewed Daniela and I, and he spent the day, and communications wasn't involved, and that was okay. 7 or 8 years ago, that would not have been okay. So that changes over time, but there is, the year before that, for example, we made several days of work right in the crux of my really busy field season, tagging Atlantic salmon smolts during the striped bass spawning run. And it's a predation study using predation tags, and they were pretty new at the time. And they made this beautiful video, and this is an NHQ comment that's now disappeared to going on 2 years now. And I don't know who has a problem with it or what I said or what I did in the video. I don't think there's anything, but you know, so we don't always have the freedom, and there may be good reasons why things get held up, and sometimes they're not very good reasons, but they're practical ones. We have translation policies and things like that. So our communications can be a little cumbersome at times, but that is a conduit in. This was just don't read the slide at all, except to say that that sort of reminds you of the regional structure and the duplication. So if you put in DFO org chart on Google, which we've already established as well within your skills, you could do that, and you see down to the regional director generals. And I know who my regional director general is. Above that, it changes, cabinets get shuffled, the influence on me it's not really important for me to track. Probably where things get real for an on-the-ground biologist or research scientist is with the director of science in your region. So that's Alain Vézina in our case. And so that's kind of the highest level where I would have a direct interaction. Other people like Fred or Sarah or Shelley Denny from UINR, like at that level, there may be communications higher up for big funding proposals and big initiatives and things, but in terms of the boots on the ground people, it's usually up to your director of science. So this is just an example of, this is the population ecology division. So one of a number of divisions under, in the science branch in Maritimes. So just in terms of relationships a little bit, so we have a division manager, and then there are sections. So we have 4 sections, and so population ecology division, that's not likely to get renamed or changed in a hurry, but the sections within the population, they'll decide that shrimp is now going to be paired up with lobster because those scientists are working together on a collaborative agreement and it's easier. So there's a fair bit of shuffling. Salmon tends to stand on its own, but we've been diadromous before, so striped bass and sturgeon and things mixed in. Now those species are separated out, so there's a little bit of flux at the section level. And we will get into the job sections, the kinds of jobs that you might have. So the person who's the salmon section manager, so speaking of management, that person is very heavily involved in administration of science. So they need an understanding of the science that's happening within their unit and the resources that are needed. And they're generally a BI4, so they're a biologist, and we'll talk about those levels. And then, so within the salmon section, for example, in this example, we have the Inner and Outer Bay of Fundy Assessment Unit, the Southern Uplands and Eastern Cape Breton Assessment Unit, we have a genetics unit, we have biodiversity facilities, and I magically managed to leave my own unit out of there, and I kind of, that's because it's new, so I'm the Marine Threats Unit, and you're looking at it. Right now, it's one person. Whereas like the biodiversity facilities are dozens. So there's a lot of different needs within those units and a lot of staff turnover and crossing back and forth. So within those units, there are generally biologists are usually BI2 or BI3. There's really nowhere in there to work as a BI4 without going up to the section management level. And then there are research scientists who can be levels 1, 2, 3, 4, 5. And that's kind of the closest thing we have to an academic professorship are the research scientists. So an important distinction is that there are opportunities based on your academic progress to go from one level to the next. So you can, if you're productive enough as a research scientist, you can go right up to that's what you'll hear, res. You'll hear the terms of res doc, that's a document. It's a paper that's published in the CSAS office, and then a res sci or a res as a research scientist. Then there are technicians. I don't know how they came up with EG, but if you look for a job and you see EG, 1, 2, 3, 4, 5, those are technicians. And then there's other staff. You'll see GL man, which is general labor, and then there's all kinds of other levels in there. So in communicating with the, I mentioned the CSAS office, so I'll talk about that a little bit. And then the other place that management comes in is in resource management. So those are the people usually, depending on the size, so like a lobster, there might be 2 or 3 of them because of the size of the fishery and the way it's divided up and the money and everything that's involved. But for salmon, there's one person, and his job is to, I only joined his lines to IBOF, to the 2 assessment units, so he interacts with all of us, but his job is really to take the science advice that's provided on and make management decisions. And in his job is much more open in terms of considering socioeconomic and cultural aspects of that. So, for example, for First Nations, a common conduit of communication with DFO management would be through the resource manager, because that is the person who has that as a big part of their mandate to consider First Nations issues in the way that science advice is interpreted in the making of decisions. So when you're thinking about trying to communicate with DFO, I guess you really have to think about what your goals are. Are you trying to collaborate? Do you want to be co-supervised and get your hands on DFO data and resources? Do you... I put that one in based on... I changed this one yesterday. I didn't mention it during the talk about NSERC grants, but in terms of funding, I mean, I actually thought of it at the time. That's a great time to already have relationships in place with DFO, because sometimes the way the work cycle happens at DFO, we don't make progress as quickly as we could like, and we end up sitting on quite a bit of data that taxpayers paid for. And I mean, that's certainly something I often have around is data and projects, and so I came over here in this case and I contacted Glenn Crossan, and that's how I ended up co-supervising Daniela. So as I said, I'm an army of one, so I have no staff, so I work with Daniela, but then I have other money for expensive tags and receivers and boats and trucks and things like that. So there can be good opportunities there, but like any of these relationships that we talked about this morning is fostering them and communicating early. It was one interesting thing I noticed with the Tyson was telling us about the tenets of working with First Nations. And I think actually if you go back to that presentation and you reread those, like the older I get, the more I realize my grandmother was right about everything, right? If you read quite a few of those, they're like, treat others as you would like to be treated. That's kind of what a lot of them are, right? Don't just come at the last minute and stuff something in my face. Talk to me about it early. Involve me. Care about what I have to say. We all want that. So that goes, of course, a different reason for it, but all those aspects, they're kind of life skills that if you want to communicate with DFO, you would be applying them. And I would suggest, I think most of what we would be talking about is actual fulsome collaboration on projects or access to data. That's what comes up quite a bit. And my suggestion there would be to be working at the leads of those units. So people like me and the leads of each of those units, they're the people who kind of have the connection to know what the needs are, what their resources are. They're the ones who understand what level of QA/QC has been applied to data. If you just make a data request at a higher level for a pull from a data set, it's a little bit different with telemetry data because we have OTN helping us ensure a certain quality of the data. But some of the assessment data, if you just pull from it without talking to the assessment leads, there's all kinds of aspects of survey design that introduce biases. You need to understand all those things, and it's if you're going and it's a time commitment from the person you're asking it from. So if you have an existing relationship, it'll go a long way to getting what you want. I called this one "Mind the Mandate" because it's something that I've learned over time is that the difference between academic goals and government mandate and deliverables for regulatory purposes. So we have a lot of things. Even though I don't work on stock assessment, there's a certain, everybody's jobs are cyclical. There's end of fiscals in every organization. But in stock assessment in particular, if you're interacting with stock assessment scientists, you need to know that they really do work on not necessarily an annual cycle. There are different depths of stock assessment that are done. So there are just status updates, sometimes yearly, using a very established method. Then there's full stock assessments if things are really changing, and then there's something called a framework, which is when they say, I want to talk about and review this new model that I want to apply to this. So people are working on this cycle, but there are certain things that happen once a year that really make government scientists really busy. And so that's what I call this regulatory workflow. So many of you apply for permits for things. So if that has to do with salmon, I see those. So a lot of my time from January to March is reviewing those permits. Any requests for introductions and transfers. Aquaculture is a big thing right now. Various funding proposals, and then ad hoc science requests that come in for, in my world, a big one is a siting of aquaculture sites. So I may think that I'm going to sit down for the next month and do this. Wrong. This other thing will come up. And so, again, that's not unique to government work, but it's very prominent in government work. And you should just keep it in mind when communicating and looking to collaborate and asking for things, what other people have on the go and what their priorities are. The other way I find it sort of important is that sometimes you can have government science done at a level to meet a regulatory priority. So we have a regulatory responsibility to provide science advice, which is usually requested through formal means, would be through the CSAS office. So they will say, we want to know what the potential implications of this action are on this stock or species. And so we may do the science work and answer that question, and then we have a shifting priority on to the next thing. And these are the types of data that are sometimes sitting there with a lot more opportunity to be taken farther, and they're not necessarily capitalized on. So it's worthwhile to have relationships as an academic with people who have access to these data, because very often, if you have a good relationship, you'll know that there are people who wish they had time to just ignore all those regulatory things and sit down and take this further to the next level. And a lot of people don't mind at all if you're the one to do that. So There's that, the fiscal year cycle I mentioned, and then just the realities, which I've kind of alluded to a few times, of political cycles under different governments. So what are the fulsome priorities under different governments, and then even how they change under majority or minority governments in terms of how quickly things move or don't move. We talked quite a bit about data, and we, especially over the last few years, the Government of Canada is moving towards open data policies, and we're progressing ... because, as is often the case, it's such a huge thing when they start taking an inventory of the data that are sitting around in a not very open way. And some of them, they'll say, well, okay, well, we need to make that open. Oh, but wait. There's all these reasons why you can't just make it open, because there's these intricacies of the data and how it was collected, or there's people possessive of it or whatever. So they tend to be looking often for low-hanging fruit to say, yep, we're meeting this mandate, we've made data available, and tracking data has been one of those low-hanging fruit, so they're able to say, that's great, it's publicly available, and we're documenting it, and we're putting it into OTN, and there's an established protocol. But this is a real thing. The corporate knowledge of the QA/QC that's been applied to the data, how to write the queries to extract data. Sometimes it's stored in really archaic databases that you're not going to be able to work with it, and you shouldn't necessarily trust the data directly without that expert opinion on where it came from, and that a different vessel was used that year, and it's not necessarily captured that happened, so there may be gear changes along the way and things. So again, that's where that communication is really important. And then privacy laws, that's one that sometimes you think, well, why can't we do this? And with commercial fishing data in particular, there's a certain level of resolution within which you can't share logbook data, for example, because if it narrows things down so much that there are too few commercial fishermen represented, then you could put in the request for the data, narrow it down, and you would know, well, that's Erica. I now know all her hotspots for fishing. Right? So that's privacy laws. So sometimes it has to be very broad or redacted in some ways, and that's just the way it is. It's especially common with commercial data, logbook data, and things. So the CSAS office, they provide this consensus-based record of scientific results and advice. So these are stock updates, and all the way up to the res docs, the research documents, which is kind of the highest level of review and rigor in those papers. They're often relative to DFO, well, they're always relative to DFO's mandate and work. So it's not necessarily as simple to say, well, I'm tagging these smolts with these predation tags, and I wrote this up, and I just want it published in a quick little document, because that's all a resource. So often the root of this type of work would be to go towards peer-reviewed literature, unless it's directly relevant to something about DFO's mandate. They have an annual schedule, so it is, again, a conduit. If you are involved in a certain type of research and you want to know if it's going to be treated thoroughly by the Government of Canada, you can contact the CSAS office and say, is there any discussion of this problem on the books for this year, and behind the scenes they're looking much farther into the future. One thing I've experienced a number of times is people coming to meetings because you can be invited to these meetings, and so people come from outside DFO, and it would be really useful to read and understand and expect a fairly direct adherence to the terms of reference of the meeting. So it's and that's just linked to the mind the mandate caveat again, that the point of the meeting is going to be very defined, and often to the provision of science advice for a regulatory need. So it's a little bit different than what you might experience in other scientific settings. And then I already talked about resource management and what their role is. So they're a main client for science advice, so they'll be the ones putting in a formal request for dock assessment advice for the 2020 snow crab fishery for this region or whatever. So that's their role, and that is an open conduit for communication with DFO. But just keeping in mind that they have they request science advice, but they have a lot of other things, legal precedent and all the other stuff they have on their plate when they are making decisions. By the way, all these photos I put in is just because my talk was really dry looking, so I'm infinitely cooler than this talk would suggest. So I break many propellers a year and I do other stuff. So this is getting into the getting a job with DFO section. And we've already had, last night in particular, we had to see how did you get where you guys were, right, in the panel discussion. So that's what I mean by non-normal trajectories, and we've heard about it a number of times. Rob's talked this morning, journalist, marine biologist, how do people get where they're going? And I think I'm not unique in saying if you talk to anybody who's kind of stabilized at a place in their career, you ask them, it's very rare that somebody said, that was my plan right from the start, and I just went on that path and I did it, and that's where I came to. So in my case, I trained to be a police officer right after high school. Some parts of me were suited to it, but other parts were not at all. So I never worked in that field, but I spent 4 years on that. And then I worked as a fishing guide and did that for a little while, and a ski instructor, and thought that would be a great career except for the grand sum total of $12,000 a year salary, so that didn't work out. So then I went back to biology, and so I came here to do my PhD with Jeff Hutchings over in biology. But when I was at the University of Guelph doing my undergrad, for one summer, I had a job with Bill Beamish as a summer NSERC student, and most of the time, if I wasn't electrofishing for sea lampreys, I was cutting them open and taking a little biopsy. These were larval sea lampreys under a microscope, cutting them open, taking a little biopsy of their gonad and sewing them back up. So I maybe did 500 of these, let's say, over the summer. And I moved here, and I moved in with friends of mine who I had known from Guelph, and he worked for DFO in the salmon section. So I finished my PhD, and I let him know, if I ever had an opportunity to meet some people over at DFO, that'd be great, and I was doing a postdoc here with Chris Taggart and Daniel Rosante. And so he called me one day, and he said, we're tagging smolts on the Stewiacke River. Do you want to come out and help? So I thought, great. I'll carry some buckets, whatever. So I showed up, and the lead assessment biologist said, okay, doctor, I've heard a lot about you. What do we do? You just tell us what to do. So I've only started admitting this recently, but I thought, okay, this is one of those moments. I can either say, that was 15 years ago, and I'm going home. Sorry, I was here to carry buckets. But instead, I went back to the truck with a suture, and I stitched a nectarine. I was like, right, yeah, okay, and I did it. So I just bluffed it. And I went back, and I said, you know how to do the anesthetic? Mix the anesthetic. You do this, you do that. And we tagged smolts, and the project went well. They got papers out of it, and that was great. And also, I went back to BIO that day, and they said, sit over here, and here's a paper to read that we're working on. I was like, geez, they're really getting their money's worth out of this volunteer day. And they said, come down here and meet this woman. And so I went over and met this very nice woman. She had some paperwork. And I was like, oh, cool. I'm going to get a little per diem, a little honorarium for my work. And I was like, 90 days, casual. So I just signed it, and I called Chris Taggart, and I said, I'm not coming back right away. I got something else going on. So I took a leave of absence, and I never went back. So, it's some of that's luck. Some of it is... I don't know. It's always a fine line between guts and lack of brains, just going ahead with putting tags in an endangered population of salmon when you didn't really know what you're doing. I don't know. Maybe not a good idea, but now I'm back. That's the Stewiacke River, and 10 years later, I'm back working there. So that original experience turned into which I'll get into, different levels of being hired, some of which then opened doors for internal postings, and I got one of the last biologist jobs under the last Conservative government before some fairly major reductions, and did shrimp stock assessment for 5 years, and then with the change in government, a new salmon position, this marine threats job became available, so I'm back working there. So jobs with DFO. So do you want a job with DFO? I don't know, maybe you don't. But your academic specialization versus flexibility, that's one of the things that I found as I started there. So they said, well, you're going to do shrimp stock assessment now. I don't. At first, I got really hung up on, I don't think I can do that. I have this very different background, and actually, there aren't that many labs training people specifically for stock assessment. But I wouldn't, I mean, one of the things in some of the talks, you realize very quickly and that, you know, data are data, right? So when you're doing telemetry work, you're using a subsample of a population of data to make inferences about how the rest of that population is behaving. You're doing that, you're using complicated algorithms, you're using models. So there's really nothing, there are some fundamentals of stock assessment science that you should take every opportunity to learn in graduate courses, undergraduate courses on your own, but really, you know, have confidence in the applicability of your quantitative skills beyond the very specialized academic questions that you're asking now, and you'll be fine. So don't worry about that. If you're faced with that, and also if you want to work for DFO, you have to be flexible to doing that kind of work. And some of it's not super glamorous, but I did it for 5 years, even with my seasick hammock, you know, puking my guts out, going out on the boat, but I really, really liked it. I got a lot from it. I was ready to be done with it after 5 years, but the thing is, I can now say, if things change with the government and they're like, oh, we're doing away with the salmon marine threats, then I can say, oh, I've led stock assessments. I've worked with communities. I've done all that. So it's a worthwhile thing to do, and it's a big part of DFO's work, but you have to think about how flexible you're willing to be. And to flip that the other way, there are diverse levels and types of work available. So if you've gotten into graduate work and you think that you may be getting towards, yeah, this was okay, but I want to do something different. If you get into the public service, there's a lot of different work you can do. So that's a plus. There are continued opportunities for skills and career development. We'll fill out these individual learning plans and get to do things like this and more formal courses and things. So that's something that you know, you're just reaching the end of having spent a lot of money paying to train yourself. So why not let somebody else pay to train you for a while? So that I find that a really positive aspect. And then you may be depending. You may not be settled, or maybe you've moved away from family and friends and places you love, and they're working for DFO. Even if you take an opportunity locally, there are opportunities nationally that you can move around a bit. So you have that kind of flexibility, and no fame or riches. But no, it's as all of you probably know, it's a good job. But no, you won't get rich, but it can be a lot of fun. I talked about these different levels already of science jobs that might be relevant here. So the GL man is the general labor, EG for technicians, biologists, and research scientists. So in each of those, these are things you can find out, but one little subtlety is that res difference. So the progression through the pay levels is automatic. So if you start as a BI2, you'd probably start at the bottom, and you would move up through the number of levels, of steps, changes with each agreement, but it might be 5 to 8 steps. So you can expect that something like that for 5 to 8 years, you would get an automatic raise up, a fairly substantial raise, and that's the range of the pay, and that just happens. That happens for all those levels all the way through, and then you stop. And you get just cost of living increases. With research scientists, you can actually then apply. You put together a package. There's a committee at NHQ who reviews your progress by a bunch of different metrics, and then decides whether you progress from a Res 1 to a Res 2. But as soon as you progress to that, you begin the automatic step increases up to the top of the range. So that's basically how that works. And there's a lot of talk by HR and staffing people about boxes. So they, like right now, I'm trying to get them to create a box for me, which would have a BI2 in it someday, hopefully soon, because the smolts are coming, right? So, but it's important because let's say they said to me, okay, you're going to have a BI2 indeterminate, which is a term as close as there is to permanent in the government. So let's say it said to me, okay, here's a box and it's permanent and it's a BI2. And somebody is staffed into it, and they should know that there aren't really mechanisms for changing the levels within those boxes except for the res. So if it was staffed as a BI2, it's not you come in as a BI2 and then you'll move up. You'll move up to the top of BI2, but that box was created as a BI2 because there's a job description for what a BI2 is, and somebody has decided that that is suitable at that level. So nothing is impossible, but it would be unusual based on to just change the box, because there are rules about that. So maybe there are people who didn't apply for that because it was a BI2, but if I make it a BI3 for you, then people could grieve that and say, well, I would have applied if I knew it was going to be a BI3, etc. So just know that if you're applying for something, it's relatively easy to move laterally at that level, but to move up a level would be usually a new application process for you. So this was the what HR sent. It's called Cracking the Code, which is really HR admitting that there shouldn't be a code. It should be simpler. But no, they're just helping. It's actually a helpful video. I'm not going to show it here, but you can check it out. But it's a helpful video because it tells you really some of the things that trip people up as they go through the process of applying. So that's kind of the direct route for getting into these pools and inventories is through the website, and you can watch this video and you go through. So that's their hot tips, right? So there's the website, and there's YouTube. You crack the code. You can all do that. So I think I have equally hot tips to give you, and I'm kind of saying that sarcastically. These aren't really hot tips, but they're things you might try. So if you know somebody who works for DFO, I get an incredible number of emails called In the Loop, and you don't get them. And those talk about things like, oh, there's this new section being created. So there's information, and there's a lot of other stuff in there you got to weed through. But if you know somebody who gets In the Loop, and I don't mean only gets the email one, but just make that personal connection. But that is one simple thing. I have a few people who've asked me, if you see any BI jobs In the Loop, and I just forward it to them. But just know that they're not always open to them. So sometimes those are internal postings. So don't get frustrated if there's one that you think, oh, that'd be perfect for me, but you already have to be in. So I say these aren't particularly hot tips. These are standard ways to get into any community, right? You make and maintain connections. But one specific one is once you get in some way, move heaven and earth to become a term employee. Because if you're a contract or a casual, you can't apply for internal postings. So sometimes I meet somebody who's on casual, and I think so that's 90 calendar days of 90 work days per fiscal year that they can work. And so I know that's coming up. They can't work in that setting anymore, and I think, man, that person is awesome. I know them. I want to move them into this job. If they were a term, I could say, we're going to run this internal process, move you over, as long as it's at level. So term is really the one where you can go directly and have access to internal jobs without having to compete against other people. If you're casual or contract, you're just in the pool along with everybody else, subject to the same process. Still, if somebody's looking for you, they'll find you, but it's... So as I mentioned before, almost nothing is impossible, just unusual, frowned upon, or impractical. So things happen that they'll tell you, no, you're a casual, sorry, I have to go internal for this. And then you come back over here to Chris Taggart's lab, and you boot up your computer, and you're like, all right, where was I? And then they call you and say, oh yeah, it turns out it's okay. I don't know what happens, but some things happen. Sometimes it's really squeaky wheels who get the oil. Sometimes it's just... they might say they need to go through the process of saying, well, I exhausted the internal possibilities and nobody expressed interest, so now I can go by this route. But just know that just because you hear something is impossible isn't necessarily true. But really, for now, if you haven't, some of you already are already, but focus on that first step of getting into these pools, inventories, jobs, and then worry about exactly what it's going to be and where you're going to move. But that getting in somewhere particularly at a level that you might think you'd like to work as a term eventually, is really your end game. So ways that you can be involved, academic collaboration and graduate work is probably one of the best ones, because you're free and I have a slide I think I'll get to about all the things I have to do to onboard somebody to work for the Government of Canada. It's embarrassing. And usually what happens, especially if you work on salmon, is the fiscal year turnover coincides with smolts getting ready to go. So they say, oh yeah, we found you money, and you hire somebody, and you look at what you're supposed to do before, and really it's like, hi, get in the truck, we'll do that later, and you go. But students have their own kind of liability insurance through the university as registered students, so there are efficiencies there, and plus it is interesting, and it does, I mean, that's how I now work with Glenn and kind of why I'm here and things. So that's one way that if you can consider inviting government scientists to be on your committee, those can be ways to make important connections. Volunteering is way more complicated because you're a liability. So there's a lot of risk aversion about having you in government vehicles, about having you out at field sites and things, and we can get insurance, we can work around it, but again, the last thing anybody's looking for is more administrative burden. So it's not really ideal. The best way if you want to do that is usually to join, like for salmon would be to join a river group, like the St. Mary's River Association. That's a big one that we work with, and as part of that group, there's some insurance that's purchased. It's a standard process. But just to say, oh, I want to get, want to come out in the boat with you and do some work. You can see it's, mucky and potentially dangerous environment, and so volunteer is not ideal. And then those are the kind of levels. So you might get a contract. That's the kind of base one. Casual is the 90 days you can work per year. So casual, anything you can get to sort of get your foot in the door and make those connections are important. But if you can get to that term one with the asterisks, that's where you have, usually that's the last step before you can make that transition over to indeterminate, and importantly, take advantage of internal postings and movement within DFO, mat leaves. That's how I got in. It was Heather Bowlby, who's the shark researcher now. She went on her mat leave from salmon, and I jumped in. So that's the kind of doors you can get in, and those doors are, so I know some of you are in these inventories, so that's the kind of, so you want a job with the Government of Canada, just give us your name and go through these gazillion check boxes and say yes, 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 importantly yes, that you've done all these things and you attach your CV. And so that's this kind of broad, like the government's hiring, we want to know who's out there, and we'll take it from there. And then there are position-specific processes. So if they were to generate one of these boxes for a BI2 under me, I could either go to this inventory, and sometimes if it's a very particular job, I can say, no, I'm going to run and post a specific hiring process. I'm going to publish a statement of merit criteria, and if you're signed up for that website from that's in the cracking the code thing, you would find out if you've checked the appropriate boxes that there's this job becoming available and you can apply for it. Both of those can eventually lead to, you'll hear the term pools, so get in them. If you're in a pool, they have different expiry dates and applicability, but usually there's a fair bit of latitude between regions and things, so just get in them. Don't worry too much. You can always turn jobs down, but if you're in a pool, you're in a really good position. So the inventories, those are those dreaded check boxes. So yeah, don't lie. I mean, if you absolutely have no idea what something is, don't say yes, but just know that any no or blank can screen you out, right? So if I'm looking to draw people from inventories, I'll look down that list of 1,000 questions, and it's designed to be, at least in the initial stages, somewhat blind to who's in there. So I don't know the names. I just submit to HR. I say, I want somebody who has said yes to this. And if you've said no to it, I may know who you are. I may be hoping your name turns out, and it doesn't. And that's because you left one blank. So just don't be too humble, I guess, is really if there's anything you can put in there, because it's a very normal procedure for me to screen people out. So I do a draw from that inventory, I get a long list, and I look down it, and I see, oh, come on. That's not, because in the little box you've said how you meet that criteria, right? So if there's something about fairly complicated and advanced statistical analyses in there, then if I look at it and it says, I did stats in my undergrad, like, okay, I'm not going to hold it against you, but I'm screening you out. That's not what I asked for. But no big deal. At least I saw your name, and maybe I'll see it again later for something else. Maybe I saw everything else that you bring to the table. So try to put positive answers in as many of those boxes as you can and let the rest sort it out. This would be my encouragement. If you go through that process, know also that your interview questions will be set by HR based on the breadth. So right now there's an inventory for EG 4, 5, BI2, BI3. And there's a set of BI2 questions that HR sends to me. So if I do a draw and I get 8 of you people who say, yeah, I'd like that job, and I look at it, just know that I could be a halibut biologist, I could be a shrimp biologist, and the questions that I'm going to have to ask you are the same. So just because you see it's a salmon marine threat, saying, oh, that's awesome, I'm a salmon guy, and then you sit down for your exam question, you're like, what? This is broadly stock assessment fundamentals and things. So the inventories are very broad, and some of the interview questions you get will reflect that breadth. I can also add specific questions. So if I look at the 8 people I have and I'm like, that's fine, they're going to answer these other questions, but I really want to know their experience with telemetry analysis. So I can add it. So you may see a specific question, but just know that there'll be very broad ones in there. So when you check these boxes and you get asked from so when I've gone through and I've said these are the 18 things I want out of the many boxes, then you will get asked, okay, tell us how you really meet these criteria. So be generous with your text in there. It's, again, some of the rules we heard about scientific writing. Don't make people look for things. And absolutely never say, yes, I've published, see my CV. You're gone, right? So in those boxes, we need to see exactly the how, where, and when you meet those criteria. So that happens more often, and it seems heartbreakingly to happen when I'm looking for a particular person to come out and they just are in a rush and they don't do a good job. So put in plenty in there and definitely never refer to your CV. Your CV gets attached for me to review. I never look at it. I don't have time. What I'm looking at are your specific responses, and just feed it to me. Here it is. Here's how I meet that criteria. So I think that's it for that slide. Another useful document that you'll see with job applications is the SOMC. That's the Statement of Merit Criteria. So there are sections for education, experience, knowledge, and abilities, personal suitability, operational requirements. So you'll see all that. You'll get a lot of information in there. There's more information you can get from that about what to expect about how you'll be assessed, and I'll get to that in the next slide. But one of the things that people almost never use is the contact person. So there'll be a job posted and there's a contact person. Contact them, ideally by phone. It's there, and to me, I look at it as we got a live one here. Like if it's just I checked the box, I kind of want a job with DFO, I'm in the inventory. I had somebody show up at DFO a while ago. They were like, I'm in town, I'm visiting my parents, I'll come over to you, can I buy you a coffee and come over and talk? Like, that's a live one, right? So take advantage of it. It's there. So, and it gives, you never know what information you can trick me into giving you. So, you just have a conversation about things. You're definitely going to benefit from that. And so what you can get from it is really these ones. Education, experience, knowledge, and abilities. So you can kind of predict how you're going to be assessed from those. So your education, if I put in, so I write that statement of merit criteria. If I put in there, I want this education, that means that we're just going to, this is one case, we're going to go to your CV and we're going to say, do you or don't you? It's binary. Experience will be either through assessing your references, because you will say, I have experience with acoustic telemetry, But that is really, it's very literal in the sense that we're going to assess that you have that experience. So what you won't be asked is, if it's experience with our code and it's in the experience section, you won't be asked in a test, write some R code. It will be an assessment of your experience, past experience writing R code. If we want you to write it in the interview, it'll be in the abilities section. So if you see experience with R and Python in the abilities section, know that when you get there, there's going to be a laptop around. You're going to be doing something. But if you see it in the knowledge section, it might be, describe the most complex piece of R code you've ever written. Oh, that's knowledge. So those are literal terms, and where things fall within there have a bearing on what you're going to see in the interviews. And I'm pretty much out of time, so I'll just make this my last slide. So what you should know, pay attention to the SOMC. You all do this all the time, communicate at a high level to diverse audiences. If you have opportunities to develop quantitative skills, it's a constant deficiency in people's applications. But know that almost everything you're doing is drawing a sample of data that represents a population, no matter what you're working on in biology. So think about it that way. And from a stock assessment perspective, try to take any stock assessment classes and personal development you can. You can get a lot of mileage about the length of a fish. So that's just a little tip I'll give you about stock assessment, that the length of a fish fits into almost all stock assessment models. It tells you a lot about fish, and you can kind of bluff your way through a lot of questions by linking things back to the length. I know because I've done it. Programming, there's a great audience for that. That's something we're always looking for. And understanding public service jargon. So you might get asked, I got asked once in an interview, write a terms of reference, and I'm kind of embarrassed to say now, I really didn't know what that was. I had never heard it before. And so I could do it if you told me what it was, but you didn't tell me what it was, and so I didn't get the job. So understand some of those terms that come up in the type of work that the public service does. And then we've kind of talked about the rest of it. Get on site, apply standard networking tools, don't be a jerk. Express interest in going beyond your assigned duties, dig in the mud for people, do whatever it is. That was actually one thing I did to get my foot in the door, was exactly that job, get a receiver stuck out of the mud for somebody. And those are the kinds of things people talk about. They're like, that guy's crazy, right? He was digging in the mud, diving down. Oh yeah, okay, well, might like that person around. So yeah, do things like go to sea, you'll meet all kinds of people, help out in the field. So once you're in, those are all pretty standard things. And this one thing I've noticed lately, I'm an old fart now, the young kids, we have some around DFO right now who wear these big headphones. They do their work. They leave at the end of the day. I don't know who they are. I don't know what they're doing. We have other ones who come to the lunchroom, come to the R working group. I know who they are. I know what they're doing. So yeah, the dad jokes are boring and everything, but come to the lunchroom. We're not that scary, but that's what makes the difference. If you come and we don't know who you are, we won't know to look for you. So anyways, I'll be around this afternoon. You could ask me more questions. I think we're going to be too tight for time now, but thank you very much.
All right, thank you so much for that, Dave. That was a lot more complicated than I ever expected, and I think you did a really good job of outlining it, so thank you so much. Next up, we have our final talk of this entire workshop series, and that's coming from Sarah Iverson. Dr. Sarah Iverson is a full professor here at Dalhousie University. She's built her career studying the comparative physiological ecology of marine mammals. Oh yeah, can you get the slides up? Thank you. Developing really pivotal software and techniques like QFASA, which estimates diet composition based on fatty acid signature analysis. And she has also been a part of OTN since its conception. So she and Fred were in the trenches in the beginning working on these grants, and she's the scientific director, has been since its conception. And so I asked her today to talk about OTN and collaborative networks because I really wanted her to talk about kind of the history of OTN, how it was conceived, so that because networks have become so popular, they're popping up all over the place, and we are future telemetry researchers, right? We are all future PIs if we want to be, and so I think we can learn a lot from OTN and what they've accomplished over the last decade, and I'm really excited to hear about the opportunities that we have moving forward. So thank you so much.
Thanks, Kim. Actually, it's a pleasure to be here today, but I hope that most of what, hey, I just lost it. Most of what I say should be pretty obvious, especially after the week you've spent here. I mean, I look around and all of you are already part of a network, and I see the excitement in the room. I've seen this excitement for over 10 years of people working together, sharing information and experiences, and having fun. And that's a really powerful, potent formula for doing science. And so Rob and Kim asked me to talk just a little bit, and briefly, since I'm the last interruption before lunch and beer, but basically how OTN came about, where does the momentum come from, where did it, and where will it go in the future, what makes a network successful, challenges, and the future, which is really, I think, about your future. OTN actually grew out of an idea from the Census of Marine Life and its decade of understanding diversity in the oceans. And it was launched by really visionary research funding from the government of Canada. And that is that explicitly paired research funding with infrastructure funding. And this has not happened before, and it hasn't happened since, which is really too bad. But it allowed OTN to simply leap to world leadership, and it allowed the Pan-Canadian Science Network to become the real research hub for OTN worldwide. Now, Fred and I have co-led, oh, that's not Fred and me, that's Fred and me, have co-led OTN since its very inception. Fred was initially delegated or tasked with directing the global infrastructure platform, and I was tasked with directing the Science Network program. And also, I have to be the primary grant holder and still am, unfortunately. But anyway, but over time, and actually pretty quickly, it basically morphed into Fred and I simply co-leading OTN and leading to what our various expertises is. And it's too bad Fred can't be here right now. So basically that funding was 2008 to 2017. That funding sunsetted in 2017. And at that point, we transitioned and became recognized formally as a major science initiative, or one of only 17 national research facilities in Canada. And what's unique about that, there's both good and bads about that transition, is that there's theoretically no sunset date. We are funded on a 5-year cycle that is infinitely, theoretically, renewable as long as we remain relevant to serving the needs of researchers in both Canada and internationally. But the one thing that we get to now think in terms of very long-term kinds of funding, but we are funded only under this MSI for operations and maintenance. We are judged on our research and training, but there is no funding for that under this. There's no paired research money anymore. So that makes it difficult, and we now spend a great deal of time always looking for funding to support our researchers. But in the context of today, I want to emphasize the really critical accomplishments that were enabled by this funding to launch a science network, which is OTN, and where it brought us in the first 10 years. We began as a diverse interdisciplinary group of some 30 to 36 variously renowned or established researchers across Canada who began to build a connected network. I was in charge of trying to get this together starting in 2008, and it was a lot of work. But by 2010, these are simply the different universities that the principal investigators are from. We tried to establish where the linkages were and to try and work towards them as best we can. And by 2014, these had grown exponentially. And a lot of this growth had to do with people like you, our graduate students and postdoctoral fellows, exchange in labs, OTN symposium that brought everybody together. And so by the sunset of 2017 funding, we then had also become much more global in our our research network, and we had some like 400 researchers from 20 countries, over 100 species tracked. And in Canada alone, from this research network, we trained over 250 students. So it was really pretty phenomenal. Now, despite the fact that that research funding went away, it hasn't stopped. And demonstrated by this spider web on drugs, in 2019, just last year, this is sort of a map of all the partnerships globally. So the momentum that we started with the launch of OTN hasn't wavered. We've just had to work in different ways. And so I want to talk about the transformation of science by networks. And of course, aquatic animal telemetry standing alone is just fine. We can learn a lot. But it's really integrating it with multidisciplinary approaches where we really take it to the next level. For instance, using multiple types of telemetry instrumentation, combining it with sampling for biochemical, physiological, or genetic kinds of work. Integrating it with new technologies and tools, such as the use of the gliders, which we've talked about, underwater hydrophones, and passive acoustic monitoring for baleen whales, the VEMCO mobile transceiver, which uses large animals to track and study the ocean, and animal accelerometers. And I not to forget the critical nature of data, and bringing that all together, and basically data analytical tools, data sharing, and which you've heard a lot about and you've worked on and understand the importance. But it should be obvious that one individual and really one lab group cannot do this on their own, and you have to be part of a network to accomplish this kind of thing. And so a really good network can be a powerful platform for sparking new collaborations and developing new tools and techniques, and also for coordinating to make sure we're not duplicating efforts. It can allow, or should allow, much broader engagement with industry and stakeholders, and allows us to coordinate better to affect changes in policy. It can provide a much stronger voice for lobbying for funding. And for the trainees, the students, and postdoctoral fellows, you're not just in a lab of 2 to 5 lab members. You have 20 to 80 colleagues or more that you're working with, that you're exchanging ideas. You're both getting and providing guidance, and this can be even much larger. And so it's really pretty powerful, and it allows the ability to bring together a global community and affect real change. And finally, I think all of us would agree, it's really fun. It's really fun to do this work together and see what we can accomplish together. And I think you guys have had fun this week, so I think you'd have to agree. And I'd have to say OTN takes a special pride in our HQP, our former Canadian students and postdoctoral fellows who have fledged, that is, attained independent research or scientific positions. And just in the last 3 to 4 years, some 15 universities and 9 government positions of our former students. And OTN, as a great network, works really hard to try and get these individuals in those places. And so these early career researchers are our next generation of OTN scientists and our next leaders. So we take great pride in that. But the other thing is that it's not just early career researchers, but a network should work to enable its mid-career researchers. And in fact, OTN has done that since its inception. And we do that by positioning our people for things like nominating them for the prestigious NSERC Stacy Fellowship, which Steve Cook won, the Pew Foundation Fellowship, Aaron Fisk, an NSERC Brockhouse Award, American Fisheries Society awards, things like this that really have, even though these mid-career investigators had established careers, it really launched them. And that was because of the network and what was able to be accomplished. And as you've heard earlier today, OTN communications team has been critical in really getting these stories out and in basically actively promoting these early and mid-career researchers and the things that we do. And because of all this, we've been able to work together to really produce some exciting pieces of work. And maybe the first big one was our invited review in Science of aquatic animal telemetry around the globe. And this was really spearheaded by the International Science Advisory Committee and myself, but we basically tasked two of our early career researchers, postdocs, to really take the lead and become the first and second authors, which obviously helped really launch their career. Another great example is Rob Lennox, who led basically sort of a similar group of people, but a little bit more broadly sampled, to envision the future of aquatic telemetry and what kind of science and training needs to happen. And that was published recently in Bioscience. And then in following that, we produced a complete special issue of the Canadian Journal of Fisheries and Aquatic Sciences, which contains some 25 plus papers that showcases OTN and how we have been filling the knowledge gaps and what the first 10 years really brought about. And so this was really powerful. And again, we did that working as a network and helping each other get all these things out. And a final example is that through the network that OTN has grown and our global community, we could put in a concerted voice to include animal tracking as an essential component of ocean observing over the next decade of ocean science. And so these are very powerful things that networks can do and that OTN has certainly done. And I just want to mention that particularly in the case of ocean science, a few years ago, the Canadian Council of Academies commissioned a review of ocean science in Canada, and they concluded that without a doubt, the questions are simply too big and too complex to be addressed by individuals or individual labs. And it takes academia, technology, federal government, citizen scientists, and communities to really launch world-class networks, and they actually named OTN as one of Canada's world-class networks. So this really has to be the wave of the future, and so we have to continue to embrace it no matter how hard we work. Have to work for it. And so the challenges are, as I've said, research funding. It was really easy with the $10 million network and easy to bring together people. That's gone away. And I have to say that I saved, penny pinched a bunch during that and managed to save some of that funding that got returned to me, and some of that's funding this today because we couldn't fund it under other sources. Networking and communication is essential. Always exchanging new ideas and asking one another what should come next for both research and policy needs, and providing mutual support. Those are sort of no-brainers, but what's really critical is network champions. And you've seen some of them here. I think I needn't go further, that you'll see that it really takes network champions to make that happen, and always thinking about the next leaders. Now, in terms of the future, we work from a strategic plan, which we revise and advance every 5 years. And so over these next 5 years, actually through 2023, we have plans like we are continuing to commit to advanced technology and infrastructure to increase our coverage. We continue to lead in development of integrated multidisciplinary research proposals and collaboration with Indigenous and local communities. We have an emphasis on leading in, as you have seen, data management, analysis, and visualization tools, and bringing these to the worldwide community and to bring them into the OTN network. And finally, diversification of communications outreach and knowledge mobilization. So all these we actively devote ourselves to, and we get huge input from not only the OTN personnel, but basically our whole community. And so the future of aquatic telemetry, I think we clearly understand how critical it is if we truly want science-based ecosystem-based management for protecting endangered species, predicting the changes of future animal populations, particularly with changing climates, improving fisheries management and coastal and marine spatial planning. And I can't emphasize enough the communications aspect of it for every single one of us. When I was a graduate student, you were only expected to publish and then move to the next paper. And as a young faculty member, the engagement of public in ocean science through all sorts of means is so critical to our work, to our support, and for really giving back to the community and affecting change. And so for the future of aquatic animal telemetry must be expanded infrastructure, continuing collaborative efforts, sharing of equipment, facilities, expertise, and data, and over ever-increasing scales, but hopefully at relatively minor increments in costs, because it's expensive to do this work, and if we work together, we can reduce those costs. So I'm going to basically finish by simply saying that OTN is a Canadian national research facility. So and a network, but as long as OTN remains relevant to the Canadian and international community, we are theoretically evergreen. And so it's critical that basically people stay engaged and enthusiastic, as you all have here. And I just want to say how incredibly proud I am of the amazing OTN team that you guys have worked with and interacted with here. And also proud of our OTN's HQPs, early career researchers, and what you've all accomplished together. And that it's just really exciting and invigorating to see. And I think staying engaged and enthusiastic is up to you guys, and it's the mantra that we all have at OTN, and remaining committed to changing the world. And finally, I think to remember that OTN is always looking for the next and new leaders at whatever levels of OTN. And so the emerging leaders that we see now, like you guys, are going to be incredibly important to OTN's future. So I think everyone that is part of OTN should constantly be thinking of that those kinds of opportunities will be coming down for people to take ever more and more leading roles. And with that, I'm going to not hold you too long from your lunch and beer, but if you have any questions, I'd be happy to answer them. Okay, well, yeah, okay. So the question is that particularly for people on the cusp and early career researchers, there's all sorts of, research and infrastructure needs and how to go about getting help with that. In that first International Joint Venture program, we had more ready leeway. But we are always seeking out new funding sources, and so the point is to come to us. Also, if you ever see opportunities that come forward that look like a really cool a grant, we are here to even help you prepare that grant. If you need equipment, we still have equipment that we can loan It's limited, but we always work to try to maximize the use of that equipment. So if equipment placed in one area or with one group of investigators is now sort of not needed, we can move that readily. And so my only recommendation is come to us for help. And we have our the two directors, but I think you saw I think John showed the org chart, but we have a field operations team, we've got the data team, we have the special projects team, and we've got the comms team. And all of them are there to basically help you and try to answer questions.
So pretty much email anybody on the contacts page? And they'll get
Except me.
tell anybody what's there.
DM Sarah.
Email Amy and Evelyn.
Yeah, I think Amy and Evelyn are yeah.
Ravi?
Thank you for the presentations. My name is Rafi. I'm studying in the US. I'm just kind of curious about the networks that have been built. I see that it's more concentrated on the American parts mostly and Europe, but I haven't seen much, especially from previous presentation from John, the networks that is built around Asia, particularly on the south part. I saw that only like 1 dot.
Yeah.
It's very small. I want to know if you want to establish a kind of being part of the network, especially OTN, it should be through like formal agreement or something, or and also like when you already become part of the network, what is the expectations of that networks among different kind of regions? The situation is that like especially in Southeast Asia right now, there is some emerging telemetry research, particularly in Philippines and Indonesia, and we kind of like share similar coral triangle region, which is like very important for many migratory animals, and we still have kind of limitations on terms of data sharing agreement, especially Indonesian government is very conservative, like especially when you want to share the data to different countries, it's really hard. And I mean, like, definitely like being part of OTN would be very beneficial, especially we have a very limited kind of capacity to do data analysis, getting more funding and stuff. And also, like, it will be great to have that connection established, but also we still follow the regulations that is existing in our own countries.
Well, so I'll try and remember the various parts of your questions. Yes, Asia is a bit of a hole. There are other holes, obviously, and some of them have to do with the socioeconomic and political components of the environment. We're always trying to push towards that. South America was completely underrepresented. We've now started to really bring people in, and exactly like what you're talking about. And here your contact is John, who's sitting across the table from you. There are formal data sharing agreements in joining OTN, and you basically join a family that's there to really help you. And I think you saw that by John's presentation yesterday. And that's you being a leader in that area of the world. And joining OTN is the first step, I think, to then possibly thinking about whether you could even establish a node there. And then you would have your own identity but could be a member of OTN. And in fact, that's what we tried to do with Brazil and have done so. So yeah, it's not easy, but you have to start somewhere. And so given that we're only 10 years young, I think we've grown a lot. And yes, the other networks, US got themselves organized. I think there was a lot of support. And so we're trying to reach out and provide support to countries and regions that don't have that support from their government.
I have a somewhat related question. I'm wondering, are there any protocols for being part of two networks, like say Ocean Tracking Network as well as European Tracking Network? Is that possible?
Absolutely. The whole idea is these are partnered, and in fact, some of them, like I mean, John could easily explain this better than me, but some of them are formal OTN nodes, but they are their own entity, and you know, you're a member of both. So you could be a member of all of them, you know, and you'd still be part of the family. What OTN does is try to bring everybody together so that there is a more, you know, globally united effort. But John can also explain a lot more about that.
I'm going to lunch.
Oh, yeah. Bombard him.
All right, well, if that's all the questions, thank you.
Okay. So one thing before I step away is that I just want you all to join me in thanking Kim and Robert for the amazing work they did in putting this amazing workshop together. So I'd like to everybody give them a really big hand. And how do I get this up? Certainly. Okay.
Sure you want to join us at Hop Here? Okay, I will. All right, so that concludes the formal talk portion of this workshop series. The next part is going to be located at Hop Yard Halifax down on Gottingen Street, where we're going to be hosting a research rodeo is what we've called it. I think it's the first time we've ever seen something like this, so we're interested to see how it goes. But basically the idea is we've gotten a couple people to pick one of the problems that they're having in their research so far right now, and they're going to present on it for about 5 minutes, giving us enough background information and ending with this question. And then for the next 10 minutes after that, the rest of us are going to put our heads together and try to crowdsource some solutions, okay? Because we're all a group here and we're all in the same boat, so let's all try to help each other out. I really hope you guys have had a ton of fun. I know it's been a really packed couple of days. The reason that it has been so packed is because we didn't know if we would ever get to have this opportunity again. Right? So a lot of this came from end of fiscal year funds or whatever, and so we don't know if we'll ever get this opportunity again. But yeah, so we just wanted to put in as much as we possibly could.
If we do get the opportunity, we'll do it.
Yeah, but I guess he just said if we do get the opportunity, we'll do it. So that being said, yeah, there has been like one little whispering of this potentially happening again. I can't promise anything. If you guys want it to happen again, if you guys want other lectures, if you guys are interested in having more training like this, then you need to tell us. And we're going to be sending out a survey over the next couple of days, so please fill it out. It would be very, very informative for us and for the OTN to be able to plan possible next future workshops, right? We need to absolutely thank our sponsors again. So our primary sponsors were the Ocean Tracking Network and InnovaSea. We also had a lot of help from Low-Tech and Star Audi. So anybody who's had a travel grant, the sponsors really helped get you guys here. So please try and thank Low-Tech or InnovaSea or OTN, okay? If you can. Is there anything else we need to say?
I just want to emphasize the importance of the survey. I get a lot of surveys in my mail, and sometimes I don't fill them out because I get a lot of them. But we'd really appreciate if you do give us honest feedback. The more people we hear from, the better these workshops can be in the future, and the better chance we can take those responses to potential sponsors and say that this was successful. We got positive feedback from a high percentage of the people, because if people don't fill out the survey, for whatever reason, we can't really take that and say, you know, we had 50 people and we got 8 responses that said that they had fun.
Yeah, we need a bit more than that.
Yeah, so I imagine some people won't fill out the survey. That's just how it is. But I hope everybody at least strongly considers filling out the survey and giving us honest feedback.
And again, thank you guys so much for being here and for participating and for waking up and getting here at 7:30 in the morning. We really appreciate it. We think you guys have been absolutely fantastic and respectful, and we couldn't have asked for a better group of people to connect with over these last 3 days. So thank you all so much. And with that, let's motor. Food should be ready down at the hop yard for 1 p.m. So you guys just make your way on down there. You can take the one most of the way if you want, or the one is a bus. Sorry. Walking would be about 25 minutes from here. We will meet you there shortly. Thank you all.